How does the fourth industrial revolution influence geospatial industry and its adoption across user segments? Are governments and businesses ready to scale up their geospatial adoption and transition to knowledge services through updated business models? Geospatial Knowledge Infrastructure, or GKI, aims to place geospatial at the heart of 4IR and knowledge economy and make geospatial everyone's business through the creation of an interconnected platform where geospatial data from different disciplines, formats, and organizations are integrated in an organized and usable manner. The geospatial ecosystem stakeholders need to work together to co-create the next generation geospatial infrastructure and develop an integrated policy framework and overarching standards for data sharing and interoperability to guide the ecosystem in the effective use of geospatial knowledge for solving global challenges. Location-based knowledge can be extracted from data through predictive analysis, modeling, and simulation, and be made accessible to a wider audience through the development of user-friendly applications and dashboards. The geospatial sector will thus migrate into the wider knowledge or technology ecosystem, focusing on services and improved user experiences, and reach into other sectors for new customers and partnerships. GKI will lead to a broad, collaborative, connected, and innovative geospatial sector focused on users' future needs, cooperating and disrupting to meet them.
A very good morning to all and welcome to yet another day of GKI Summit. Yesterday, we heard a full range of discussion revolving around the theme, making GKI a reality. We have started the day with why GKI, and through geospatial knowledge, the power of where to enrich the lives of all citizens globally. We did deliberate on integration of fourth industrial revolution technologies with geospatial platforms and services, which will enable access to many forms of data and analytics, thereby increasing access to geospatial knowledge and driving new forms of data partnership and sharing, leading to new business, new industries and behaviors. Lastly was discussed the importance of integrated policy framework for driving greater benefits for societies. Today, the second day of this GKI Summit, we will be focusing on the theme, making it a reality. We will have 4 panels in the day, and let's start with our first panel on transforming geospatial stakeholder ecosystem. So the moderator for the panel is Mr. David Henderson, the Chief Geospatial Officer at Ordnance Survey. David, the floor is yours to drive the discussion.
Thank you, Anamika, and good afternoon from the south coast of the United Kingdom. Good morning, good afternoon, good evening, wherever you are in the world today, and especially those who have made an effort to stay with this conference in the middle of the night. I could see some people doing that yesterday. Especially welcome to you. I'd just like to start by offering some congratulations to Geospatial Media on hosting these really important conversations this week and releasing the associated white paper. It's a real pleasure to contribute to the discussions today. I found yesterday's discussions really very thought-provoking, and I was reflecting whether such a programme or set of conversations would have been possible even 5 years ago. Of course, many of the delegates that are with us today would have felt so, and justifiably so, and would have voiced perhaps frustration at the time that we weren't able to have some of these conversations. But it certainly seems in 2021 that there is a really strong appetite for conversations about national strategies, integrated frameworks, and the associated demand for geospatial knowledge infrastructure, the focus of this summit. Events of 2020 have made it clear that our global community is ever more complex and yet ever more interconnected than ever before through a variety of both informal and formal networks. last year, as the pandemic was in its early stages, I had the pleasure of working with colleagues at Ordnance Survey on the third edition of the United Nations GGIM Future Trends Report. In a community that for many decades have arguably been technology and data driven, it's really clear that that landscape has irreversibly changed, and at an ever increasing rate thereof. Of course, geospatial technologies and geospatial data remain absolutely fundamental, but there are many other factors that we are talking about now. One such aspect is the maturing of geospatial ecosystems, multi-stakeholder approaches to solving real-world problems, whether they're at global levels, national scales, regional levels, or indeed citizen-led community projects. The explicit recognition of collaborative geospatial ecosystems is very much at the heart of our first panel session today. I'm delighted to be joined by expert panelists who have experienced these changes and offer a range of insights into the challenges and the positive experiences of working in true partnership and in collaboration to demonstrate the positive impact of geospatial decision making. So I'd like perhaps to be joined now with our panelists for this morning. We have four panelists who will join me shortly on the stage. And I will invite them to speak in turn. It would be wonderful for the conversation this morning to receive any comments or questions indeed from the audience. You can put those into the chat on your screens. Hopefully they'll be available to us. And with that in mind, I'd like to introduce our first speaker this morning, who is Ed Parsons, geospatial technologist from Google. Ed, the floor is yours.
Thank you very much, David. It's a pleasure to join everyone, although I'm probably the closest person to David in the audience, perhaps, or certainly from the speakers. It's lovely to see the world represented, as is always the case in the geospatial media's events. It's always a great honor to talk to such a distinguished and widespread audience. I was really pleased to be asked to talk in this particular session as well, because I think it's really valuable to look at what we do within the terms of something like an ecosystem, because I think, ecosystem recognizes that we are moving beyond the sort of simple characterizations of public versus private, producer versus consumer, dealing with the various players, the various stakeholders within the geospatial community, or maybe the geospatial industry, if we want to argue that it is an industry. And maybe some of my comments will maybe focus in onto that point. Within an ecosystem, idea is what we do in industry. Are we a community? How do we view ourselves, and how does the rest of the world view us? It was interesting. I thought about the actual term ecosystem. It's something we use very often in the IT industry, particularly, I suppose, over the last 20 years. It's a term that's thrown around quite a lot to describe what goes on in software services, in the development of new technologies, new capabilities. We use the term very, very loosely. And I wonder, like you, when was the first time that you heard the term ecosystem? When did it enter your consciousness? For me, it goes back quite a long way to actually my time at university, when I was doing a course in biogeography. And I think from a geographical perspective, or at least an academic geographical perspective, it recognizes this idea of geographical determinism, the very close relationship between an environment and the organisms that live within that environment. Indeed, the original idea that Arthur Tansley came up with in the 1930s was this idea that a particular environment created a space for a particular group of organisms, and there was a very strong link between those organisms and the environment in which they were developing. In the 50s, the Odin brothers developed the idea of a systems ecology understanding, looking at flows of information, or flows between those different organisms and the types of organisms that you might have in a particular ecosystem. So, A desert ecosystem was very different to an ecosystem in the rainforest or in a moderate temperate climate in the mid-latitudes. And I think that complexity is really important to understand, that actually what we're talking about are different types of organisms, often, almost in all cases, living their lives independently, not necessarily understanding their particular role within that ecosystem. And that ecosystem is being defined often externally to those particular organisms. So if we look at that sense of what a natural ecosystem is and compare it to the software environment that we live in, I think there are some useful lessons to learn. Ecosystems today, where they've been really successful in the IT space, are often based around less formal relationships than previously we might have expected. It's often not the case that there are formal contractual obligations between different stakeholders within an ecosystem. There may be a loose formal relationship. You may be signing up to the terms of service for a particular API, but there may not be requirements in terms of levels of service that are expected from that API to provide. In other cases, there may be a stronger contractual obligation. In some cases, there may be no connection whatsoever. You look at the modern APIs that the web has been built upon, often they are very loosely coupled systems, that, as we described them, with no real connection between the different organizations. That allows a very dynamic framework to appear. It allows one service, one organism in the ecosystem sense to be switched out from another one, to replace it with a different service providing the same functionality, providing the same capability. And chaining together those different services is the way that the dynamic web-based applications, the applications that we have on our mobile phones, are developed. And I'm really pleased to see organizations like the Open Geospatial Consortium coming on board with this very much API-driven approach of loosely coupled services that very much reflect the blueprint, the model for the wider internet. The internet itself is built from these loosely coupled services. And I think that is an important blueprint and gain for moving forward. If we look at the supply chains that we are going to be having to use and support moving forward in a post-COVID-19 world, many of those supply chains are going to be lengthened. The nature of supply chains has perhaps been more complex than many organizations wanted to have as an experience of COVID. And a reassessment of supply chains will no doubt be taking place across the board over the next few years. That said, brand, I think, is still important within the ecosystem. How do you choose a particular service? How do you choose a particular provider of information remains an important element to this. And particularly within the geospatial scope, clearly the quality of data and the quality of service is a very important function. People will go to reliable providers of data that have consistency, that have systematic accuracy, that have levels of currency that are documented and can be identified. But in the same sense, I think there is that recognition that because this is an ecosystem, and organisms will fill particular niches within that ecosystem, the combination of different services, different groupings of stakeholders is important. And I guess a current example of that is the work that David's organization has recently done. They've developed an OS Maps application that runs on your smartphones that in the UK uses mapping provided by the Ordnance Survey. But in Australia, a new market for Ordnance Survey, they're making use of OpenStreetMap data because it fits that particular niche, that requirement for data in that particular area. That, I think, is a really good example of this complexity of ecosystems, of bringing together different groupings of services, different groupings of stakeholders to meet a particular need. And the need, I suppose, is in some case that environmental constraint that we talk about from an ecosystem point of view. My final point is one about, I suppose, context here. And this is a fundamental question, I think, that we've always had from a geospatial point of view. from our perspective, what is the ecosystem? Where does the ecosystem exist? Is there such a thing as a geospatial ecosystem? My argument is that actually for us, what we do in terms of geospatial technology is just one organism within a broader ecosystem. The ecosystem might be the application area that we're interested in. It might be actually a geographical area. Crucially, geospatial isn't the environment. So geospatial is just a component. It's just one of those organisms within a broader ecosystem of different services, different data sets, different applications, user interfaces, enterprise systems that meet a need of a particular market or particular set of requirements. So we may be quite a large organism, maybe a dominant organism, a predator perhaps within that ecosystem, but probably in reality, we are just one of many organisms independently going about their lives, going about their businesses within a broader ecosystem, creating an environment that is healthy. And I think that's an important perspective for us, to recognize that geospatial is an important component in many different services, many different functions for many different requirements. But in almost all cases, it's not going to be dominant. It's going to be something that interacts with other services, other systems, other types of data. And we need, I think, to expect and to be open to building these loosely coupled frameworks, these loosely coupled relationships to allow us to be dynamic, to meet the needs of future sets of requirements, future niches, to use the other biological term, in the future. And that's fine. I think if geo ends up being, invisible in many future products and services, but nevertheless, fulfilling an important role, that's fine. The map of the future, as I've often described, may well be invisible, but that's not a bad thing. Okay, that's the end of my comments. I'm looking forward to the conversation during the rest of the presentation, and thank you for your time.
Thank you, Ed. That was absolutely excellent as a start, and really sets a range of different things, which I'm sure will give rise to some comments shortly as well in the chat. I've got some questions that I'd love to put to you, but I'm going to immediately go over to our next speaker, who is Serena Kose, Professor at the Department of Geography, Geomatics and Meteorology at the University of Pretoria. Serena, thank you ever so much for taking up the next slot in this panel. We look forward to hearing your talk.
It's been a very interesting discussion so far at the summit. I particularly enjoyed yesterday's session on data collaboration and partnerships, where the panelists emphasized the important role of people. And I think also listening to Ed, in an ecosystem, it's all about communities and it's all about people. So I want to carry on this theme, looking at how we have to transform the individuals behind all these stakeholders, or the individuals that are part of the ecosystems, and how they have to prepare for the future. And my perspective here is painted by my background. I think that's always impossible to avoid. So I'm looking at it from a perspective as an academic in a country in Africa. And I also work a lot with data sets that are collected and maintained at local authorities. So I think a lot has been achieved in the last few decades in terms of how geospatial data is used. Many people use it these days. They don't think about where it came from, how it was collected, who visualized it, where it went. It's a bit like Ed said, it's becoming invisible of where you're getting your data from. And some of this has been because of standards, it's because of technologies, and specifically, I think also because there's a move and a drive now to integrate geospatial information with mainstream IT technologies. If you just think of something like GeoJSON, everybody in the IT world knows how JSON works, so then using GeoJSON is the next step. But where things fail, it's seldomly because of standards or technologies or things like that. When things fail, it's usually because of people, because the people are the ones signing those agreements. The people are the ones joining a certain community and an ecosystem. They are the ones who approve budgets. they are the ones who have to make spatial data available. So I think the people are really important in this ecosystem and also in the future. So people who work with the geospatial information not only have to understand the value. I think a lot of what we did in the last 20 years was convincing people about the value of location-based information. I think going forward, we are seeing still this explosion of data, and what's becoming increasingly important is how you govern that data and how you manage that data. And in that context, I see three challenges for Africa, and especially for local authorities. So the first thing is that the data sets that you get at local authorities are usually things that are maintained by complex business processes. If you think about something like addresses, there's a whole process of consultation. There are things like social and cultural identity, so you can't just randomly pick names. They comprise different components. There are other things like zoning, for example. They also need to use to involve a consultation process before deciding on things like that. So they're not the kind of data sets that you just fly a drone and then you have all your information. Although, of course, technology can help, but there will always be this element of human intervention. And the local authorities, apart from the fact that these data sets are difficult to maintain, the local authorities in developing countries tend to be, well, I don't know whether understaffed, but usually the staff are less skilled than what you would find at a national authority. I think this is due to the fact that national authorities maybe have more money. They usually have their head offices in cities where people with skills tend to go. So all of this results in a situation where you don't have critical mass of the right skills at the local authorities. So then, if you look at the individuals also that we have to educate so that they can work at these local authorities, they need two things. They need to understand the value of geospatial information, and very often they get this from working in a field like town planning or spatial planning or zoology. But then with the explosion of data, we also need those skills in terms of governing the data and managing the data. And what we see in terms of education is that many of those programs in geography and those applied fields are just too full. There is no space for teaching them about data, for teaching them about ethics, about managing a master data set, about versioning it, about interoperability and these kinds of things. So you end up with people in the industry who have a background in something else, and they don't know how to manage the data, or you could also get all the IT people or the data management people with those skills, and then they don't have the value for the geospatial information. So I think going forward, this is still, I think it's always been a bit of a challenge, but that challenge has not gone away. So in order to maintain the geospatial data sets at local authorities and to get the critical mass, I think we need to widen up the ecosystem of people who contribute to the management of geospatial data, not only looking at those from the geospatial community, but looking also at the others, and then it will become a larger community supporting the maintenance of the data. And I think, especially in terms of data sets at local authorities, we can't get away from this. This is like really essential if you think about the rapid urbanization that we have in countries like Africa. I mean, managing those cities, you need geospatial information, and that information needs to be managed by the local authority so that they can manage their area of jurisdiction. Thank you.
Serena, that was really excellent. And I know you have to go shortly and leave us this afternoon. So I have one immediate question that I'd love to maybe just ask of you. I think it's a really excellent insight into some of the human aspects that sit behind the success, if you like, of any ecosystem in that regard. I wonder, because you talk about a lot of data being almost manually created. I think, you know, in the context of Fourth Industrial Revolution type of thinking, more and more data will become automated. Automation will become more prevalent, machine-to-machine communication will become more prevalent. I just wondered how you observed those same human tendencies being applicable in that future world.
Yeah, I think you're right about the automation and the machine-to-machine communication, but this will lift the level of, or the requirement of the human. So instead of just sitting there and digitizing streets on a satellite imagery. The human has to now take responsibility for managing the data, for thinking about the ethical implications of that data. So it creates this demand for higher level skills also in the geospatial domain. And I think if you look at the digital ecosystem idea, is that it is scalable. But I mean, to make that scalable, we also need to be the human resources to be scalable. So we have to make sure that we can increase those levels. Yeah.
And the other thing that I was left thinking about listening to you was the importance of the voice of the owner of the use case, the person who had the demand for a particular project or a particular set of outcomes. In a world where some of these ecosystems are developing at much bigger scales, even global types of scales, and maybe we'll pick this up with Ed in the broader conversation. How do you facilitate the connection between essentially global ecosystems and individuals who are working on particular projects? How do you see that playing out?
Yeah, that's an interesting thing, but that's where I think the idea of the ecosystem is a very powerful one, because if you look at the ecosystem, there's a big ecosystem, but then there are smaller systems within. And you can shape your environment in that you are working. So the local authority could be part of a bigger ecosystem, but they can shape the way in which they interact and communicate and direct that ecosystem. So I think there are lots of opportunities. So it's not something that gets globally imposed on them, but they have the opportunity to shape how they interact, I think. Yeah.
Yeah, and it really plays to the notion of the informal connections being so important within that ecosystem. Yeah, Serena, thank you ever so much. Thank you ever so much for being with us today. I appreciate you've had to make some time today in a really busy schedule. So thank you for being with us this afternoon, and good luck with the rest of your day.
Thanks. It was really nice. I am very sorry that I'm going to miss the discussion. That's always interesting. Thank you. All the best. Thank you.
All the best. And with that, I'm just going to hand over now to Jones Ofori-Bodu. Jones is the one of the Deputy Executive Secretaries of Corporate Services at the Lands Commission in Ghana. Really pleased to have you here, Jones, and looking forward to your talk.
Thank you very much, David. And good afternoon, good evening, good morning, everybody here. So I wanted to say thank you to Ed and Serena for their excellent thoughts on the topic, and more especially Serena on the Africa experience. So I'm going to share some thoughts on the geospatial community and digital mainstreaming. So geospatial community deals with location and data geographic components, as the previous speakers have already talked about. And it includes records in data sets, having locational information attached to them. Forms of locational data, we could say, are coordinates, address, zip codes, as the list goes on. And the geographical community comprises of GIS analysts, mapping professionals, developers, users, software analysts, academia, etc. And this community comes together to share common interest in all things spatial and non-spatial. So you have a community of several professionals who come together to share data, both spatial and non-spatial. So digital mainstreaming also comprises of digital tools to communicate on the internet, digital devices, smart devices, and other technologies. These may include practice within an environment that regards it as conventional, like a conventional environment, and such as Internet of Things, cyber physical systems, artificial intelligence, AI, big data, virtual reality, and others. These have been incorporated into the fourth industrial revolution. So some views of bringing the geospatial community and digital mainstreaming together. It is most efficient and effective way to collect, process, integrate, and utilize information for overall global, national, and individual development. Geospatial knowledge is a result enabling us to identify, contextualize, and understand the many challenges and opportunities facing society within a geographical context. And there is a vast information availability for processing. There is a possibility of large investments since industry is expecting a great digitization drive. And I believe that in the next few years, we're going to have more of this, in industry. It helps governments, industry, academia, and citizens to build a digital economy and society that can embrace knowledge and automation. So what needs to happen in all this collaboration, stakeholder engagement, and having it within the ecosystem, as has been talked about? So there has to be opportunities, and opportunities will have to be given to all stakeholders and all collaborators. There should be a deep commitment to education, more especially in where I am in Africa. We need a lot of education into things with respect to digitization and automation of data. And then there has to be deep collaboration and innovation. And then also there's a need for investment in providing access to authoritative data, geospatial knowledge, and technical resources. I want to talk briefly about the Ghana situation. So before we had these outdated maps, we had huge volumes of manual records of geospatial information, such as maps, files, ledgers, notebooks, and all these are information, we had information sitting in all these mediums that, if you want to process a document, you need to fall on all these manual records. Limited internet infrastructure. And then there was an inadequate ICT infrastructure. Now and moving forward, what we want to do is to provide medium-scale maps to cover the entire country, which has not been done for so many years. We are making a deliberate effort to automate geospatial data capture, storage, retrieval, and dissemination systems, because we realize that the manual processes don't help anymore. We need to move into the automation of the processes and also putting them in the digital environment. And then we're looking at investment in key ICT and physical infrastructure to support the automation drive. So things like putting up data center where all the data will be archived and then retrieved within real-time retrieval processes. And then also engagement with geospatial and user community to adopt a collaborative approach, which is very key to us, because we need to engage with several users of our data to make sure that we are churning out the right information, and they are also getting the right data that they want to use for their purposes. So talking about the local assemblies, local authorities, district assemblies, the financial institutions, the law courts for case judgments and stuff like that. So thank you very much. I think I would end here with my presentation, and thank you.
Thanks, Jones, for the really excellent presentation. Thank you for sharing with us the status of geospatial developments in Ghana. Really, really interesting and really helpful to identify so many important themes, which I know we'll come back to in the discussion. So thank you for your presentation. And I would just like to now pass over to our final talk from Basanta Shrestha, who is the Director of Strategic Cooperation at the International Center for Integrated Mountain Development in Nepal. Basanta, thank you for joining us this afternoon, this evening, and I ask you now to give your talk.
Thank you, David. It's my absolute pleasure. And at the outset, thank you to Anamika and the whole Geospatial Media and Communication. It's my pleasure to share some thoughts towards realizing a vision of GKI for the Hindu Kush Himalaya. Perhaps I would say a journey towards realizing a vision of GKI in the Hindu Kush Himalaya. This is an image from space of the Hindu Kush Himalaya, and the region is endowed with immense natural capital in the form of ecosystem services that provides sustenance for almost 1/4 of humanity living in the mountains and largely in the downstream. Also, from the ecosystem point of view, perhaps mountains exhibits one of the complex kind of ecosystem in the world. And here we are talking about the geospatial ecosystem, and we also see, as previous speakers has pointed out, some of the complexities that we are dealing with the geospatial information and knowledge for the benefit of the larger society. Now, this is an image of 1921 in the high mountains in one of the glaciers. Now we see the enormous kind of changes that are happening by different drivers of forces. And this is a repeat photography of almost 90 years. So the kind of changes that has brought about, talked about climate change, and the Hindu Kush Himalaya region is one of the hotspots from the climate change point of view. And the kind of unprecedented changes that we see on the mountains in terms of climate change, the whole kind of a demographic change, and also the population dynamics, land use, land cover change, and many other changes that we witness today. And I believe that geoinformation technology and the knowledge services provide means to understand these changes and to guide our policy and programs in a more sustained basis. So the Himalayan region perspective, and because of its inaccessibility, remoteness, and in order to gain the understanding about the complexities of this ecosystem, perhaps sometimes there is no other means than the space technologies, space-based resources, and the geospatial kind of information and a technology that provides a means in terms of gaining our enhanced understanding about the kind of changes that we see. And if you look at, as previous speakers also pointed out, in terms of the complexities of the geospatial kind of ecosystem, if you like, from the ecosystem point of view, and also geospatial knowledge infrastructure, if you look at it, I think the speakers earlier also highlighted multi-stakeholder partnership. And if you put the people on front, both there are the kind of a diversity of the users that we need to deal in this ecosystem, both from the horizontal and the vertical dimension. Horizontal meaning that the kind of different disciplines, whether it is a climate change, whether it is a rural development, urban development, kind of a different disciplines, water, air, and so forth. So we need a lot of this sectoral kind of information base. Now, if you look at the vertical kind of a dimension in terms of the diversity, we need to be able to see this sort of a knowledge infrastructures provide supports to communities, and in our case, the mountain communities, and all the way to the policy decision makers. So I think we are dealing with quite a fair amount of complexities, not only challenged by the mountain ecosystem itself. When we talk about the GKI, the kind of complexities of the whole geospatial ecosystem that we deal with, and if we put the people on the center stage, how do we really drive our shared vision and goal to have a geospatial knowledge infrastructure? How do we really create impacts and synergy? And also, I think in the context of the pervasiveness of this technology and also the increasing use of these services, how do we really enable and manage the kind of diverse stakeholders and enable the kind of a growth that we would like to see? Now, if you look at from the technology kind of a diversity point of view, and if you like from the fourth industrial revolution, which is the main theme of this topic, the kind of a technology convergence that we are seeing, and also I think this convergence, particularly from fourth industrial revolution point of view, these are providing enable kind of a transformation. What we are seeing is a immense democratization of the information and knowledge services. We are seeing the kind of infrastructure as a problem solving infrastructure, which is almost like self-regulating, self-governing, and enormous amount of digital transformation that we see. So I think in the context of the technological ecosystem, again, the challenge is how do we really put this technology infrastructure in the hands of community, in the hands of different diverse stakeholders, I mentioned earlier in the slide. Now, in terms of some of the GKI kind of in the Indo-Himalayan region perspective, that one of the key things that we are driving is how do we really support from the science point of view? How do we really support from the technology and innovation point of view, so that our evidence-based decision support for planning and sustainable development at multiple scales can be happen? And we are using multiple prong approach in terms of especially the 5 key focus in terms of user engagement and co-development of products, in terms of data information sharing and the knowledge services. Also looking at the mountain region and the kind of a region that we are dealing with in a remote location, and also the kind of a constellation of the different member countries in the Indo-Himalayan region. Some are in a very advanced stage in terms of using geospatial information and technology. Some are in a moderate kind of a stage where we need a lot of capacity building and also the networking, and also science applications and the decision support. And also one of the key mandate is the key focus is from the regional kind of perspective. How do we really foster regional cooperation and the international partnership? I also would like to highlight here the Survey program supported by NASA and USAID. This has been one of the key program in terms of driving geospatial technology and applications in ICIMOD in present day. Now, some of the thematic applications, again, we are knowledge organization dealing with issues like climate change and the sustainable development agenda. So we are looking at a lot of co-development of these different applications: agriculture and food security, land use, land cover change and the ecosystem, water and hydroclimatic disasters, weather and climate, and also the air quality, and many other thematic applications. The backdrop of image here, I think, is a image of a recent Uttarakhand flood, if you like, the kind of also hit the news worldwide in terms of the kind of typical disaster we witness in the mountain environment. Perhaps I think it's a paradoxical in one way that geospatial knowledge or the space technology provides means to understand very quickly the kind of calamities and the disaster. On the other hand, I think we are also challenged and confronted by kind of information and the knowledge services that we provide to first responders or to gaining this sort of understanding. In my view, I think we need to look at the ecosystem approach in terms of advancing our knowledge, and geospatial technology plays a very, very important role to that effect. My last slide, we are also talking about the international partnership. So mountain region requires a very special attention due to inherent characteristics of remoteness, inaccessibility, and also the challenges that we face with the climatic and other conditions. We are also interfacing with geo, and also we are promoting Himalayan geos in a regional kind of a constellation to provide geographic information and the knowledge services. We often view that Hindu-Kush-Himalaya region is a pulse of a planet. If the pulse is not good in the Hindu-Kush-Himalaya region due to climatic and other changes, the pulse of the planet also, I think, gets affected. So I think it's all the more importance in terms of putting emphasis in a geographic knowledge infrastructure for the Himalayan region. And these are some of the aspects that we are looking into from the ICIMOD as an organization in the region. Thank you, David. Over to you.
Thank you so much, Basanta. At the end of the presentation, you finished on a very similar theme to how Ed started, talking about the biogeography of as a kind of starting point for thinking about ecosystems, and we finish with protecting the pulse of the Himalaya. And there's a nice circle in the presentations. And thank you all for sharing those thoughts with us. There's a couple of thoughts that have kind of gone through my mind, I guess, is to the maybe just start with the sense of an ecosystem being relatively unstructured but working together, and the sort of informal nature of the ecosystem developing, the connections, the relationships in it. But I'm sort of driven by this sense that the whole needs to be greater than the sum of parts, and therefore it's important that there is some form of structure, some sort of cohesion within any ecosystem in order that its value is delivered effectively. I just wondered perhaps whether you could all perhaps just reflect on that, and within the ecosystems that you're all developing, where is the emphasis to ensure that the whole is always greater than the sum of the parts, and that the ecosystem can deliver its maximum value. Ed, maybe just come to you first, if that's okay.
Yes, thank you. I mean, it's a really interesting topic of discussion. In different times, it would be a great thing to sit in a bar with a beer and have a long philosophical discussion about this. I mean, I think the points you raise perhaps identify some of the difficulties with the parallel that we draw with natural ecosystems, because clearly the organisms within a natural ecosystem have very little agency. They don't collaborate in the sense that we as humans do. And that loosely coupled, almost sort of chaotic nature of a natural organism, the sum of the parts is the sum of the parts. There is no greater element. And that's where, human agency, where what we do is different. And I think, as I said, there is the danger in drawing too much of a parallel. Where we add value are in those I suppose, aspects of design and engineering and identifying what are the key elements of an ecosystem that act as a multiplier that will allow us to have a greater impact by collaborating and making discrete choices about the elements that we choose to combine together and work to solve a particular problem. But I think that it's still helpful to view the environmental part of an ecosystem as something that is important to understand when we look at this, because it frames the problem space. It identifies what are we trying to achieve, what are the context, what are the constraints within which that we are working. But your fundamental point is correct. When we talk about ecosystems, we are talking about that multiplier that comes from connections from a social point of view. But the value, I think, still is in identifying that those relationships perhaps can be much less formal than they were traditionally.
Thanks, Ed. And Jones, I'm conscious in one of the slides you had an important point about coming together to ensure authoritative data. And I think within the concept of an ecosystem, I'm really interested to understand the balance between those relationships coming together, those informal structures, but still having something at a national level that can consider to be authoritative within that, and how you think that comes together.
So I think that is very critical for moving forward in terms of the cohesion and then the collaborating effort in the ecosystem. Let me take the Ghana example for instance. In Ghana, there are several agencies, as you may be aware, several departments, and each department is collecting its own data. Some of the data are in different formats, so they cannot even be integrated. And therefore, everybody is collecting data and they're living in silos. And much as they would want to collaborate and have a cohesion in their efforts, the data is such that it's difficult to even bring together to support the collaborative effort. And so moving forward, that's why we're talking about the authoritative data. So it's like collect once and use by many. So one organization is made in charge of data collection, get the primary data collected, and then all other departments and government agencies fall on this data and are able to use it. What we're trying to do also is to make sure that government supports the collection of this data, and so giving it to other users should be free. And then when you add value to it, then you could, get some revenue from that. But the primary use of data, we're looking at it going to agencies for free, so that can help to bring the collaborative effort stronger together. So that is the way of thinking we're looking at, and then also moving from the manual way of doing things to the digital environment. That helps much more in the collaboration than going through the manual process.
Jones, thank you. And to Basanta, I think you have probably a very unique perspective on aspects of partnerships and sustaining collaboration, and the time and energy that is required to bring stakeholders together to achieve common good and common outcomes. I just wonder how much in your experiences with the work that you've been doing in the Himalaya, it has been a people-based problem rather than a technology and data-based problem, and how you've ensured that these stakeholders understand one another and understand the outcomes that they're working towards.
Thank you for the question, David, and it's my pleasure, and I think, to share some thoughts on this. Of course, that we operate in a very challenging environment, not only in the context of physical kind of challenges that we face with the mountain ecosystem, but also on a geopolitical environment. I think bringing together different member countries in the region with a different kind of a capacity and the capability, again, our whole perspective is from the ecosystem point of view. One is a technological ecosystem, in terms of IR and in terms of the different kind of technology, what can be most useful in the context of certain applications where these are very local level, for example, community-based early warning system, to a very kind of a regional kind of applications in understanding the dynamics of glacier change and so forth. So I think the kind of our experiences over the last 2 decades is in terms of an ecosystem. If you look at the people at the very center stage, in terms of looking at some of the challenges, not looking from technology per se, but some of the challenges that we are trying to face, and we see more sort of a system and a service kind of approach, given the kind of challenges, and bringing the kind of different stakeholders together, first to brainstorm and also look at the kind of challenges and the feasible technological solution that leads to a co-design, co-development, and a co-ownership of that sort of a system. And if I may give an example, for example, community-based early warning system, perhaps using some of the geospatial technology and the wireless sensors network. Technology is not so much of a context in that, but the community, those who faces the flash flood, unless they create a ownership, this doesn't really, work in the context. On the other hand, if you look at the climate hotspot point of view, so our entry point is a climate disaster. So we need to bring together these member countries in a regional collaborative framework in terms of data and information sharing, in terms of understanding the kind of a complex phenomenon that is ongoing, so that we can act upon some concrete action to the national governments at the national level and at the regional level. So there are varieties of other examples, but again, to end my comment here, we put the people at the center of an ecosystem and see how we can drive some solutions using some of the technological innovation.
Thank you, Basanta. I'm really sorry to everyone, because I think this is one of these conversations, as Ed said, that we could continue to have for much of this afternoon or this morning, this evening, wherever we all are. It's a fascinating subject area of our industry today, and indeed how we contribute to greater value. I think in the conversations we've had some really interesting global perspectives, particularly from technology. We've reflected on national priorities, local priorities in South Africa, and heard some really great examples of regional projects from Basanta. And I'm really conscious that in the next decade ahead of us, as we face into sort of COVID recovery, the economic challenges of the world, the challenges of resilience and sustainability to our planet, the aspects of working together in collaboration and in partnership are absolutely key. And I think many of the conversations both yesterday and today will demonstrate just how well equipped the geospatial sector and geospatial industry are to contribute to some of these challenges. And I think we've heard a little bit this morning already about the collaborations that we have within ourselves, both public, private, and indeed citizen-centric, and how those are coming together to make a real difference. So with that, I'd just really like to thank Ed, Jones, and Basanta this morning, this afternoon, for your time, for joining me in this conversation. I wish we'd had more time to go further, but with that, I'll hand back to Anamika.
Thank you, David, for driving such an interesting panel. Definitely, it was interesting to hear all of you, and we wish we would have had much more time to have this discussion on. So we'll meet you again after 5 minutes for our next panel, which is on process automation and standards and interoperability for achieving GKI.
Good morning, afternoon, evening, wherever you are, and welcome to the second session of today. I'm John Kedar, and amongst other things, I'm very privileged indeed to be working with Geospatial Media and all its partners, driving this debate on the future for geospatial through the Geospatial Knowledge Infrastructure concept. And what a range of people and experiences we've had so far together at this summit. The diversity of panelists, whether from government, industry, international institutions, academia, and individuals from every continent in the world, with many different challenges, makes this conversation incredibly valuable. And this panel is absolutely no different. My task today is to moderate this panel on process automation and role of standards and interoperability for achieving GKI. I'll introduce the panelists in a minute, but let me just have some introductory remarks to set the scene first. So, fourth industrial revolution technologies are delivering vast amounts of data, but most of that data is unused, and in amongst it, of course, there'll be value, but there'll be nuggets of gold out there somewhere. But on a much more sustained basis, the automation of processes can help achieve one of our 5 goals within geospatial knowledge infrastructure. And that's the idea of continuously updated, trusted, and open national foundation data. And to do so in a far more cost-effective manner that perhaps we've ever seen to date, so that all nations and societies can benefit. The second point I want to make is around GKI seeing knowledge at the heart of tomorrow's global digital society. Geospatial is complex, yes it is, but it's not special. And to improve knowledge, understanding, decision making, the whole digital community, including geospatial, has to come together across industry, government, education, and Serena's points in the last session about education and people, very important in that regard too. And this requires both a cultural and policy shift, but it's also absolutely one of interoperability. Interoperability helps us work together and helps us be stronger together. And my third of 3 points to introduce is fake news. Well, it's not so much fake news, but fake news has been a hot topic, including throughout this pandemic. But good decision making has to be based on knowledge that we can trust and we know the veracity of. So we need to be able to trust data, we need to be able to trust information, we need to be able to trust knowledge. And therefore we also need to be able to trust the algorithms, the tools that we use to derive that knowledge, particularly where we have no human in the loop, which will be increasingly the case in the future. And this trust relies in part on assurance in the quality and provenance of data, and partly on understanding the principles, the assumptions, the bias, and the processing of the analytical tools. So those 3 points are all related in a sense, and illustrate that for our discussion today, which is about process automation, interoperability, and standards, all of these things are interlinked. So if I could introduce my panelists, that'd be great if they can be brought onto the stage, as it were, and I will say hello to them all. Great. So I'll just introduce them, then we'll get them with their introductory remarks up and running. So Dr. Nadine Alamy will be well known to most people as Chief Executive Officer of the Open Geospatial Consortium. We have, if I'm looking, just checking we've got everyone. Dr. Kumar Navalur is Senior Director, Strategic Business Development at Maxar Technologies from the USA. John Lipinski is co-founder and president of Ecopia AI from Canada. Abhijit Sengupta is head of sales, Southeast Asia and India from Here Technologies based in Singapore. And Alex Kaganov-Talmor is the data services lead from the Intelligent Mobility Solutions division, Mobileye, which is an Intel company and based in Israel. Welcome to you all, and thank you very much for joining us. You'll each be invited to speak for about 6 minutes, then we'll have a short period of discussion at the end, as we've done with all the panel sessions. So without further ado, I'd like to invite our first panelist to give her introductory remarks. Nadine, the floor is yours.
Thank you, John. I am gonna share. So thank you, John. Thank you, Geospatial Media. Thank you, Anamika. Thank you, Sanjay, for organizing this event. So to get my 2 points across this morning here, Washington, D.C. time, sunny, I'm going to refer back to a presentation I had to do earlier this week for another event. And they wanted me to talk about, do we still need standards today? Not just geospatial standards. And it didn't take too long to think, you know what, this is not what we should be spending our energies on, whether we need the standards or not, or what's the role of standards. Because I would challenge anybody how we're gonna go from data, information, knowledge, put wisdom on hold for a minute. How do we get from data to knowledge at scale, right? At scale, operationally, without standards. And I go back to my favorite example from my aviation days, and that's the SpaceX example, right? And this is the end of 2018. It was all over the news, the real news, right? So just a couple of years ago, the US airspace had to close for 3 hours, 1,300 miles of airspace when the SpaceX rocket, December 2018, went up, right? They closed the airspace for 3 hours, even though I think we all know The rocket was out of the airspace in 90 seconds, and the booster came back in 8 minutes, 8 minutes later. So 2018, they tracked for the SpaceX flights, 1,400 flights, our regular flights, right? Our flights, passenger flights were affected. They had to fly 70,000 extra miles to accommodate, those new space launches from SpaceX. And that was 2018, when we had only a few and just SpaceX. And today is a totally different world, right? But why? Because there was no way to exchange the information from the rocket ecosystem, right? Information that's geospatial, location and debris related, right? With the US air traffic management system. When we talk scale, we look at space, a tweet from Cesium this week, January 2021, 3,000 active satellites out there. The small sats, what was it, 2019, 385 launches. In 2000, there were 1,000, so times 3 and more and more. But think about how many of these satellites are collecting data. So I'm happy to see Dr. Kumar on the panel. I think he'll tell us more. But terabytes and terabytes of data, useful to a lot of people for so many applications, so many domains, and especially so many new businesses hungry, right? Startups hungry to use them and combine them to make our lives better. I want to hit you with scale, Internet of Things. Who hasn't heard of it? This from Gartner in 2020, 5.81 billion. Again, billion devices that we're trying to connect somehow to make sense of our world. And smart cities, we've heard about it in this event, but this concept that we want to be able to connect information, retail, real estate, infrastructure, health, cities, government, energy, transportation, underground, so that we can, I call it gamify smart cities or city planning. I don't know how in the world we're going to be able to make this vision a reality without this common understanding of the basics, without the foundation to link this system of systems, or what we're hearing earlier, this ecosystem. And I know everyone is sick of COVID, but it's still here. I swear, I feel like there are 1 million dashboards out there. There's even ratings for these dashboards, but within OGC, the number one issue we hear is that everybody is having to go back, difficulty connecting to the data sources in the back end, the data formats, the interfaces are lacking, the interfaces change every day. The interoperability essentially is lacking. And it's not just COVID, right? It's any threat at a global level. We just heard in the previous panel with the Himalaya. Like climate change, nobody, no entity, no one has all the data, all the tools, all the models, all the processing, all the use cases, literally nobody. So we need to start thinking about not, do we need standards? I think we need to agree, do we need systems to talk to each other? I think yes. Do we need organizations to share data around location? Yes. Do we need to solve the problems? A big yes. And the standards are the foundation of this ecosystem. So I think the two questions I'll leave you with are, we need to focus our energies on one, which standards do we need in this interconnected world and which ones we're missing? And two, how do we get those standards out at this pace of innovation? And when I look at what we're doing within OGC, it's getting your data to your mobile phone. It's connecting the sensor things. It's the GeoJSON for drones. It's the OGC APIs to access everything that has location in it. It's the models behind the APIs. It's all this spatial temporal stuff, right? It's how do we exchange analysis-ready data? How do we know the fit for use, for purpose? This is what we're spending our energies on. And I think what we're standardizing today is different what we're standardizing yesterday. And with that, how do we get those standards at the pace of innovation? So my final thoughts, John, I'm seeing we're now collaborating at a totally different level. The standards are not an afterthought. We're not standardizing what we already have. we're collaborating on a foundation on top of which innovation can thrive at scale and operationally. We're all being proactive, proof we're all here, right? More partnership building than ever. And what I think is bubbling up is this integrated approach to innovation rather than traditional standards development. And lastly, I say it every time, standards, interoperability, they're not magic. We have to work at them. We have to invest in them if we want to get what we want out of them. So these would be my thoughts, and I look forward to the thoughts of my fellow panelists.
Great, Nadine, thank you very much. And I think your point about the speed of innovation is one we might come back to because it's absolutely critical. I don't think any of us will argue against standards for interoperability. I'd like to ask John Lipinski next to give his introductory remarks.
Yeah, it's a pleasure being here speaking today. So at Ecopia, we're leveraging AI to create a digital representation of the real world. And Ecopia's data is embedded into customer applications spanning over 100 countries around the world now. And today I'm going to talk about some of the ways in which we're leveraging AI to drive automation and accelerate the geospatial knowledge infrastructure. So I'll start by setting some context in that within the next 30 years, the world's population is expected to grow by nearly 25% to 10 billion people. And to handle this growth as a population, we really need to gain a better understanding of our world and optimize how we live within it. So here's what that means to us, is having a living, breathing digital representation of the real world within a computer. Some would call it a digital twin. So this means not only having the ability to understand the properties of the real world, but also how they interrelate and having the tools and capabilities to leverage that information efficiently for decision-making purposes. So to give a few examples of this, it could be understanding how to best place solar panels throughout a city, providing tools to better manage city assets such as roads or parks, gaining an understanding of how and where to place telecommunications infrastructure throughout a city, and even assessing the risk of insuring any given property. So why hasn't this been done yet? Well, there's a lot of factors at play. Specifically from our standpoint, we think there are 3 pillars that have really changed the game and made something like this possible. So I'll go through them one by one here. The first is that geospatial data is following Moore's law. So data from satellites, planes, street view cars, even smartphone sensors, more of it and better data is becoming available every day. And by creating an ecosystem of these sort of data sources, Ecopia is able to access an unprecedented amount of geospatial data from around the world. And the second is that machine learning is really coming of age. So the emergence of deep learning and other breakthroughs have brought machine learning to the point where it can help solve real world problems. And our technology at Ecopia was built upon PhD research at the University of Waterloo, leveraging these methodologies, and the outputs are now embedded into some of the largest corporations and federal governments around the world. And the third is parallel computing has moved to the cloud. So 5 years ago, few people knew what a GPU was. And now you can rent 1,000 of them or more on Amazon Web Services at any given time. So we've built a highly proprietary framework to help leverage this power. And in our opinion, these 3 pillars have really changed the game in how we visualize, analyze, and understand our real world. So with that, I'm going to talk about 3 specific examples of how this sort of data can be used. And the first is telecommunications infrastructure deployment, which of course is essential not only in cities, but in rural areas as well. So here's a very simplified representation of Ecopia's 3D mapping solution being leveraged for 5G deployments. And by leveraging this map, we can gain an understanding, or our customers can gain an understanding of the potential obstructions throughout a city, such as bridges, trees, and buildings, and understand and model out how and where to best place 5G sensors throughout the city. So we're really excited that this sort of data is being leveraged to help accelerate the next generation of telecommunications infrastructure. Next example I want to talk about is autonomous vehicles. So of course, autonomous vehicles have a ton of sensors on board, but they still rely very heavily on highly accurate geospatial data. And here we have an actual map that we've created as part of the Autonomous Vehicle Innovation Network in partnership with the Ontario government. And we call this an HD map because not only does it include detail of the buildings and roads, but it includes a much higher level of detail required for autonomous vehicles to navigate the real world. This is just a preliminary version as we're in the process of creating it, but we're really excited about this project because it will map, this map will form the framework of infrastructure for autonomous vehicles that we hope to expand around the world. And the last example I want to touch on is within the NGO space. So we started working with large NGOs around the world a few years ago, specifically starting in Africa. And before our work with them, these NGOs were working to help make sure that everyone had access around the globe to resources such as healthcare, electricity, and education. But they ran into almost an unbelievable problem, and that was that they couldn't locate where the populations were, specifically across the continent of Africa, because they didn't have adequate maps there. The best maps that they had were hand-drawn, such as the one shown here. And here's what we've done to help. So just a few months ago, in partnership with Maxar Technologies, who I believe is the next panelist here, we completed the first ever complete map of every building, road, and forest across sub-Saharan Africa. So this data is being leveraged by folks like the Bill and Melinda Gates Foundation for use cases such as enabling more efficient healthcare distribution across the continent, assisting in the deployment of sustainable infrastructure, and aiding in the monitoring and policing of deforestation. So with that, I want to circle back to our vision and wrap up here. So as the population grows and our world becomes more interconnected, we really need to gain a better understanding of our built environment. And our vision is that through better geospatial data infrastructure, we can empower our population to make better data-driven decisions. So that's all for me. I'll hand it back to John. Thank you very much for your time today.
John, thank you very much indeed, and very interesting, and your range of examples covering, the high end, the automation, through to helping in sub-Saharan Africa with NGO work, a really good range of examples, and it just shows how that combination of data and AI can come together to open doors. Next, I would like to welcome on stage, and he's already just been referenced, Dr. Kumar Navalur. Kumar, floor is yours.
Thanks, John, and thanks to Geospatial Media for the opportunity. When I think about process automation, the first example that comes into my mind is Ford's Model T in the early part of 19th century. The interesting thing was, if you remember the saying from Ford that you can have Model T in any color as long as it's black. The reason was the automation they have created in that chain. The time it took for the paint to dry, black was the best color. So when we talk about process automation, we have definitely moved as an industry from a data poor to a data rich paradigm. The key example I can give you is I'm actually a civil engineer by education. I would be in the field with a laser taking maybe a few measurements every hour. And if people remember, something is called theodolite that actually preceded laser. Now you have these terrestrial LiDARs that can collect 1 billion points in an hour. So we are now collecting so much data. Going back to what Nadine was saying, we collect around 80 terabytes a day today as Maxar. And by the end of the year, when we launch our Legion satellites, we'll be basically tripling that capacity. So there's a lot of data that's being collected, not only by us, by the various sources Nadine has already mentioned. So that means we need to start thinking about how we can actually harness this data. John, going back to your opening remarks, I heard one statistic that 80 to 90% of the digital data is never looked at or analyzed. So we're looking at a lot of data that's not even being processed. And also a former director of NGA, this is now 3 years ago, made a comment that the data they were seeing at that particular agency, he needed 8 million analysts to extract some of the features that from the data they're receiving at that time. So we do not have enough eyeballs and we do not have enough resources to handle the new deluge of data. So standards, I think, are becoming very much key so that this can be actually done fast. The other one, which I'm actually very actively involved in, is the timelines. John just mentioned about autonomous cars. It's the speed of decision making. Once you have the knowledge, this could be a machine in this case, it not only has to process the data, but it also has to make a decision. That's where the knowledge is created and action has to take place. We're talking not only seconds, maybe even sub-seconds for autonomous cars that are coming in the future. So when you step back and look at the developments happening in the field, standards are absolutely required for interoperability. And the second topic John also mentioned is AI/ML. When we talk about standards, it's not only just about the data, but also the taxonomy that goes with it. I had the pleasure of growing up in India. Now I'm in the United States. Little differences where we call semis here in the United States, lorries in India. So having a taxonomy that can connect so that these machines, especially machine-to-machine interfaces, which we anticipate in the coming years, that the standards becoming very relevant. And going back to the pyramid, where it's not only for the data, we're talking about having this taxonomy and exchange standards for also information and knowledge, so that these digital twins and others we are creating can not only process the data, but also can make intelligent decisions in almost real time. So for me, stepping back, the key things would be is let's think about not only data, but also think about the entire value chain of the GKI. And standards should be thought about not only just from the data perspective, how do we transfer the information, not only from machines to humans, humans to machines, but also to machine themselves. So we're in a very interesting world, and this panel, I think, is starting to address some of the key issues and why standards are very much relevant for us to operate in the future. Back to you, John.
Great, Kumar, thank you very much indeed. And actually, I was very taken by your point there about looking across the whole of GKI and standards and interoperability. Yes, over in the USA, you have Zs where we have Ss here in Britain. But I'd like to come back actually to the point that you make on that in questions. So next on stage, we welcome Abhijit Sengupta. Abhijit, I'll say no more, but offer the floor to you for your introductory remarks.
Thank you, John. And firstly, thanks Geospatial Media, Sanjay, Anamika, for this opportunity. Good morning, good afternoon, good evening from Singapore. While I was listening to my fellow panelists, a couple of thoughts which came to mind, and it links to the points which I want to highlight for my discussions today. Look, in the fourth industrial revolution, as we are getting ready, and we are part of it, and many countries are driving this, the potential for usage of location technology is growing day by day. What the biggest challenge is the volume of data which we have to deal with, and that's not an easy task, because the data not only has to be accessible, it needs to be usable, it also needs to be making sense for the use cases which we would like to drive. At Here Technologies, we have been dealing with this data. We have been dealing with these challenges, and we have been dealing with these opportunities for last many years. We process data from more than 100,000 sources, and do keep in mind that we are present. Our products and maps are present in over 200 countries, and we can imagine the kind of challenges we face, the way we get the data from all these countries. Previously it was mentioned there's the data might be different in two different countries, but might mean the same. And the simplest example could be the addressing information. And the addressing information in one country would be very symmetrical, systematic. It follows some pattern, and in some countries it might not. But if you look at the use cases which are being which are using the same set of data, take, say, for example, the delivery, and we have seen the delivery use cases going up significantly during the pandemic time, has to rely on the same set of data. The algorithm will try to make sense of the same set of data, which is coming from different sources. So what it means for us, and it's probably for the industry, is to think of how do we automate some of these processes? How do we automate that when do we get this data from different sources, we are able to make sense out of it. Otherwise, the use cases which we're discussing, be it the transport logistics, or automotive, or say for supply chain, or for telco infrastructure, it's not going to work. So our goal is to ensure that that how do we deal with this data at scale. We need to make this data fresh as well, and also how it can be easily consumed by the various stakeholders in the ecosystem. Coming back to the standards in the interoperability topic here, we support open standard. We support the standard which is available in the market. We do understand that it's very difficult to put the data which is available in the real world and try to make them as one, because that's not how the real world works. What is important then is to use various algorithms, the machine learning tools, etc., and to create a sense out of the various sets of data. We also understand, and that's a reality, the data is available in different silos. As an industry, I think it's important to make these more seamless, that how do we get this data out of those silos and make it available broadly for various use cases. We also are aware that there are developers who use this set of data because they want to create various kinds of services. And these services are, what we've seen in the last 5-7 years are getting created based on the needs in these various countries. And we are in a platform economy, right? We see the on-demand use cases for especially for transportation, which did not exist a couple of years back. And the fact that today we have such companies working and being successful, because what they're doing is they are able to reach out to the end user, which is the demand side of things, and also on the supply side on the platform, and able to match that through their platform. And today, not only it is able to provide a way of transportation, but it is also providing a significant amount of employment. It is generating it is contributing to the economy of the countries as well. So not only it is solving a problem which is as a consumer or user one would have, but it's more broader. So just to summarize, if you want to just kind of connect all the dots here, so one is the reality is that we are dealing with terabytes and terabytes of data. The second point is this data today exists in different silos, different format, different shapes and forms. Thirdly is, as we're seeing different use cases are emerging across various countries, this data has to make sense. And that's probably all the stakeholders who are in the geospatial world needs to make all kinds of effort to ensure that this data comes together and able to, usable at scale for various stakeholders. Our location platform, we try to do that. We have a marketplace, we have a workspace. We encourage various data owners, suppliers to use those marketplaces so that those data can be further enriched and usable. So before I hand it over to you, John, I concur with my fellow panelists that there is an opportunity. While we have an opportunity at hand, there's a couple of basic points we need to focus on, and I think that's going to help every stakeholder in the geospatial world. Thank you. Over to you, John.
Thank you very much, Abhijit. Very interesting, actually, and you didn't directly mention it, but in talking about getting data from different sources out of different silos, is how we share the value, the financial value in the case of businesses too, across the value chain, as different organizations make different use of that data. We probably won't have time to return to that, but I know it's a challenge that people are grappling with. And our last panelist to speak today is Alex Kaganov-Talmor. Alex, when you're on stage with me, we'll get you up and running. Floor is yours, Alex.
Thank you very much. Thanks for the opportunity to be presenting today. I'll share my screen in just a second. So I come from Mobileye. Mobileye is an automotive organization, and so one must ask himself, how did we come to a panel to discuss GIS applications? And actually, interestingly enough, that reason would be standardization. So not by a written rule, but by a conceptual perception of what does it mean to have a safe IV. Mobileye came to the notion of developing its own technologies with regard to AV and to digital mapping on top of what we bring for over 20 years of automotive safety, and a lot of first with regard to, so first cover only for collision warning, lane departure warning. We're now moving forward towards the higher levels of automation, right? And Mobileye has been along this path for the past 20 years. But when we're looking at vehicles that can see, and they've been able to do so for, let's say, for about a decade, and we're looking for the higher levels of automation, and those are coming quickly, and quicker than we think. Mobileye is working on robotaxi projects for the coming 2 years, and we're looking at large-scale projects of thousands of vehicles in 5 to 10 years. An industry standard that would probably be the case. So we're now at this edge where this year has been the first year where we've actually been able to have vehicles that can see and can tell us what they can see, and this is what I will be using my time to be talking about. So at Mobileye, we're building today the largest world crowdsourcing fleet, which means that today we're covering around 8 million kilometers daily, and by 2024 we will be covering 1 billion kilometers of road daily. And we're doing this with our OEM partners and with retrofit solutions that we build in by fleets. But really, the question is how. So what we've been doing in Mobileye for many years now is analyzing the driving scene. So understanding the different road users, the road scene. You can see here traffic lights, traffic signs, pedestrians, etc. And what we're using the same capabilities, the same base capabilities, into analyzing additional elements of the road. Here we can see poles and the road network as a whole. And as we're expanding our abilities on the edge collection, we've also been expanding the technology to allow us to be able to process that information on the edge and to send it back to the cloud. Because when we're talking about the largest harvesting fleet in the world, or when we're talking about millions of vehicles that are interconnected, and in the current state of affairs, the amount of detail and amount of data that we can upload to the cloud, and there were petas and teras that were mentioned on the call. All of this is something that is scalable on a very small project-based scale. When we're talking about millions of moving sensors, then we need to turn the volume down, and basically what we're doing is that we're using that input that we have from our collecting sensors to build a 3D model, which is already coded on the semantic level, and as such as sent to the cloud. Once we're able to send it back to the cloud and aggregate the different information, we're able to turn this information into scalable AV maps that are constantly updated based on the information that we collect from the ground constantly. So all those 8 million kilometers are updated or can be updated every day and can be sent back to the vehicle for purposes of localization or for other purposes of providing different safety and leisure features to the vehicles themselves. But other than creating this constantly updated level of information, we're basically find ourselves and so far of shared data from globally, but I want to use this time to just drill down a few very specific examples from Israel, where we are based, to just show you sort of what are the snapshots of this aggregated data could look like. This is automated collection from Israel, last 3 hours, of just simply traffic flow and safety events. All of this is collected in an automated manner. with no human intervention of any sort. We're able to drill down and to better understand the road network and the dynamics of the driving behavior in that, in both real time and aggregated, and to analyze different. We started this conversation on safety, so understanding where dangers occur, where almost near misses happen. We're able to report those. We can have an insight as to automated processes of how traffic looks in real time. We're able to monitor infrastructure as to the quality of the lanes for missing traffic signs or other road attributes, faulty traffic lights, construction zones, together with image extraction. And so all of these capabilities are coming to life, and those enable us both the revolution of autonomous vehicles, and as well, the autonomous vehicles are not going to be coming in silos, right? This concept has already been mentioned here. We need this information in order to modernize and to digitize the environment in which these vehicles travel. And only the combination of those two will be the one that would enable us the road to success. So that's it on my end.
Thank you very much, Alex, and thank you to all the panelists. And I think your videos, Alex, really did demonstrate how much data is being collected and can be collected all the time, and how that might be used. And actually, I think my takeaway right at the moment, before we go to questions, is just quite how much data there is and how important that automated processing really does become. Anyway, let me pick up some questions for the panelists, and I think the first one I want to tackle really is around standards, because in fact Navolo mentioned this business about the GKI value chain and standards across the value chain, and of course that means it's not just around the data itself, it's around AI, it's around the web and so on. So Nadine, for you, I guess it's how do we move with geospatial standards to take on board some of the other standards issues around artificial intelligence and around working on the web? How do you see that developing in the future?
Thank you, John, and thank you, Kumar, also for bringing up this point and for this excellent panel. I was also taking notes like crazy. It's good stuff. So I think back to your point, John, I think this is where I'm honestly beginning to realize, as you know, OGC or the geospatial community, the types of standards that we're having to think about are different. Like you're saying, it's not just about data access anymore. When we talk about FAIR, so I appreciate Abhijit actually bringing up, you know, findable, accessible, interoperable, reusable in his talk, right? We need everything along the value chain. So we're talking, for example, how do we discover or exchange training data set for AI ML? This is definitely something we did not do a few years ago. We're even talking about, and I think this importance of, when I mentioned the models behind the APIs, we're standardizing the APIs, but also those models, especially when we start to bridge worlds, like we were seeing here, whether smart cities or the connected vehicles, because, you know, what we use in, you know, the models, even model interoperability, right? The models in hydrology and their impact on flooding for a smart city response and, you know, public safety. So all of that, I think this is what Kumar was saying. So you got the taxonomies, you got the higher level standards for the training data sets, the discovery, and then, you know, we're all talking, you know, linked data. That's, I think, what we're all struggling with, right? How do you link all this data semantically and syntactically? And I think that's why we're sort of reinvigorating. We have at OGC something, the OGC reference model, right, which is our own reference system of how we look at standards. And we're actually renovating that, because first, it's not just geospatial. The ecosystem is not geospatial. It's everything, but it has a geospatial in it. And we're having to actually accommodate that whole value chain.
Okay, no, thank you for that, Nadine. And actually, I'll take it from a different perspective, the same sort of idea, but I'm going to ask John, John Lipinski, whether industry is giving enough and inputting enough into the development of standards, and where in particular you see standards needing to be developed to support your business.
That's a very interesting question, John. So I think standards are a big part of geospatial data, like any infrastructure. So if we date back to physical infrastructure, within any country, you have these standards of what a road looks like, how to build a building to code. And at the core of it, it's really important to make sure that you have a solid infrastructure and that all of that is built out in a consistent, uniform way. So that's one of the things that we're trying to get more involved in as an organization, and coming to the table and providing our input into these standards as they were formed. So to give an example, in the early days of dating back a few years ago, we did a lot of work around mapping buildings. And of course, we've now mapped buildings across the continent of Australia, the United States, I mentioned sub-Saharan Africa. But through that process, we developed a very detailed specification of what a building footprint should look like and how to define a building. And it's actually surprisingly more detailed and difficult than you would think when you start to think about the sheds comprise a building. Are you incorporating the deck at the back of the house? What about the porch that doesn't have walls? So there's a lot of details just in any given element of these sort of infrastructure pieces that need to have standards employed in them. And I would go back to the example again of physical infrastructure. I think it's just as important to make sure that we have a high degree of, high standards for this sort of data, and making sure that it is created in a responsible and in a robust way as we build upon it. Because that's really what we're talking about here, is an infrastructure that's going to be built upon for many applications, from insurance to autonomous vehicles. So that's how I would think about it.
Good, no, thank you very much. And I'm going to move slightly broader here, but open data and opening up data, because I think we both saw with Abhijit and with Alex, the vast amounts of quite useful data, very useful data, and Abhijit talked about silos. But has industry got a role to encourage more interoperability, to encourage greater use of geospatial? Has industry got a role to open up its data in a way that perhaps is non-commercial, to encourage new innovation, new ideas, new value? And I'll ask that of both Abhijit and Alex, but perhaps Abhijit, you can give me a view on that first.
No, sure. I think I definitely the industry does have a role to play, and I think the various stakeholders in the industry, the first thing to start with is sharing the importance of getting the data. I think the awareness part is important. We all know, be it the government, semi-government, or private enterprises, they have the data, and many times it is thought that the data either would not make sense, or even it makes sense, we don't know what the value of it. So it's a kind of a commercial questions as well, or what is the right value. But I think it's important that the industry, propagates this messaging that's important, and that to share model, etc. Of course, that's important. But end of the day, I believe that it's going to expand the use cases and help various and broader stakeholders, and also the stakeholders which are not part of the ecosystem. Yeah.
Okay, no, thank you. And Alex, I've just looked at my clock and we're running short of time here. So Alex, your views on the same, please.
So again, in automotive, a lot of times the standardization comes from safety. We see today, for example, in Europe, with regard to discussions on the safety, general safety regulations, government has been much more aggressive on standards than industry, pushing the industry forward. So definitely a lot of the data consecutively is open. And standards do serve, again, especially when we're talking about the public scene, is a very big catalysator in enabling data collection, providing commercial basis for it. That being said, there is always a level sort of proprietary level of data that each industry player wishes to retain for themselves, both for commercial leverage and for in the end that there is great effort that is entailed in obtaining the data, and that is as such in many times is considered a competitive advantage by itself.
Okay, no, thank you. And I'm going to call a halt to it there just for time reasons. There are many more questions I think we'd all like to ask each other, but it's absolutely fascinating, and I'll thank our panel in a second. But throughout the summit, we've heard about the importance of interoperability and standards, not just in this session, but time and time again, because this ability to partner, to collaborate, does require us to be able to integrate through standards and so on and so forth. And also we've heard about some of the challenges in getting good quality data into a number of nations around the world. And, you know, process automation, as we've seen, doesn't just help the sort of developed nations, the rich nations. It can help all nations in improving their use of geospatial. And I think that's really important to pick up on too. On closing, I'd also just like to highlight an announcement made today by Geospatial Media of 50 rising stars of the geospatial knowledge ecosystem. These are all the younger generation, certainly a lot younger than me, selected from around the world in open competition. If you're interested during the break, just search on your browser for Geospatial World Rising Stars and celebrate this younger generation's great achievement. So in closing, thank you very much to our panel today for bringing insight into the discussion. Nadine, John, Kumala, Abhijit and Alex, thank you for your time. And we'll now take the sort of customary 5-minute break between sessions, and then we'll be back up and running again. Thank you.
Greetings to all of you, and welcome to the 6th panel session of the summit. This panel session will be dealing with the topic of co-creating geospatial infrastructure and services and evolving business models. I suppose it's quite appropriate to have the session now because it does really follow on from the earlier panel sessions today. Co-creation is said to be a new paradigm in the way in which we make products or provide services. It means working jointly with others, including our clients or users, to create greater value than what we could achieve on our own. This requires communication, cooperation, coordination, and collaboration, or what can be termed collaborative synergy. The issue of synergy was raised earlier in the session moderated by David, but we'll continue that. It has been said that the 4th industrial revolution requires geospatial knowledge on demand, and that is one of the objectives of GKI. This geospatial knowledge will be derived from a multitude of sources, many being non-traditional sources, across various disciplines from surveying to environmental science, to agriculture, to demographics, to economics, and many more. In many applications, it will be required almost instantly. It will be imperative that the process from data acquisition to knowledge creation be a smooth and rapid flow. So, how would GKI meet the needs of the various and numerous users of geospatial knowledge? What is required from each of us, and what are the business models necessary to achieve collaborative synergy? Fortunately for me today, we have a panel of esteemed panelists to provide some of these insights. So our panelists are Prashant Shulka, President of Global Geospatial Group from Canada. Welcome, Prashant. Ingrid van den Berg, Head of the Belgium National Mapping Agency. Welcome to Ingrid. Vijay Krishnan, General Manager of Intel Geospatial from USA. Welcome, Vijay. And Joe Sakiskos, sorry if I pronounced that incorrectly, CEO of Syntony Corporation from France. Welcome, Joe. Let us, for the sake of time, let's start then with Prashant. Over to you, Prashant.
What I would like to do is first and foremost commend the organizers of the Infrastructure Summit for putting this together. And I also want to send out a shout out to whoever wrote the report. In my own view, that is a report that's exceptionally well written, and it gives us a perspective on the geospatial knowledge infrastructure that I think is a bit of our Rosetta Stone as we go forward. So hats off to whoever wrote the report, hats off to Geospatial Media for hosting this session, because I think it's an important session for a number of reasons. One, it does speak to the evolution of things like spatial data infrastructures. Second, it speaks to the evolving ecosystem, and it is a timely discussion given the existence of the COVID environment and what we're going to do in a post-COVID situation. So I've been asked to talk a little bit about co-creating the future, specifically in relation to business models. Now, one of the things that I would like to do is really kind of think about how it is we start thinking about, hang on a second, I'll just pull this up. So how is it that we actually go forward and think about the things that bind us? Many of us are familiar with this particular image, and it shows what we've done in the geospatial world in terms of linking humanity, as well as our cities, our communities, our countries, and our world. What's always struck me about this particular slide and this picture that we use to demonstrate our connections to one another is the fact that there's so much of our world that's unconnected. And in order to try to create those connections, we've undertaken very significant events to link, integrate, and even define things. So we've taken steps to explore the reaches of space in order to look back at our Earth and observe it. We've created an environment where we receive the data that people have talked about today, the terabytes, the exabytes of data. We've even thought about things at a global scale to bring together that data to harness our efforts to address some of our most pressing problems surrounding humanity. We've even talked today about how it is we connect everything from deep space to the satellites to these global development goals through things like standards. And at the end of it all, it's really about trying to connect to the individual person that is in need of our services, of our data, of our technology, but most importantly, about our humanity. So that's why I believe that as we talk about business models, as we talk about our technology, as we talk about data, we've undertaken a lot of work to integrate, to link, to build together, to create new ideas, but there's a lot more that's left to do. And I think it really begins by rethinking the concept of collaboration. I think many of you that have heard me speak before have heard me talk about collaboration actually enhancing competition that is friendly, competition that is mutually reinforcing, and competition that is not a winner-take-all mentality. And for those of you that like listening to podcasts, I would suggest that you listen to this particular documentary from the Canadian Broadcasting Corporation that talks about how standard-based environments like our geospatial environment actually can help lead industrial revolutions. And the screw that changed the world was really about the revolution that helped power the creation of the modern rail system. And many of us have actually talked about geospatial as the modern rail system of the 21st century. And we've talked about the fourth industrial revolution. And I think we all have the capacity and the capability to think about the screws that are going to change the world the next time around. And so one of the pieces that I'm familiar with, that I've worked on, are concepts like business models. And one of the things that I find particularly difficult in the geospatial community is that we are often speaking to one another about these absolutely wonderful applications of technology. And make no mistake, I'm not criticizing that. We're talking about the wonderful applications of the data. We're talking about the human potential that's associated with them. But often in the discussion, what we forget is that we operate these technologies, data, and systems in a global economy that is based on business model relationships that are themselves an ecosystem. In 2021, the World Geospatial Industry Council will be releasing an extensive report on public-private geospatial collaboration, specifically looking at public-private partnerships. I've had a hand in that. And there, we're going to examine 10 different business models that are specifically linked to public-private partnerships. People have often talked about data as a service, infrastructure as a service, or business to consumer, business to business, consumer to business business models. There is an emerging concept of data trusts, which are themselves a very radical and transformative idea that I think it's time to seize upon them in the 21st century. And it also, I think, leads us to reconsider what the concept of a global company is and how a global company behaves in an environment that is really an environment that is shaped by a very profound context. And it requires a fundamental reset. We are plagued, as John had referred to earlier, about issues of false news. We're plagued about the digital divide. We're plagued with issues of income inequality. And these issues, this context, provides us with a profound opportunity to move forward with very different business models, with very different approaches to co-creation that move beyond just the bottom line of a business, just beyond the concept of value for money for governments, that moves beyond the interest of just national interest or corporate interest. And it's a fundamental reset that I think, in terms of how we co-create, is important, because in order for us to move forward, that fundamental reset has to occur before co-creation can even begin to occur. Thank you.
So Prashant, thank you for those insights, particularly the way you are indicating that we need to rethink on the collaboration and the term of friendly competition, and also what we need to do with respect to the new data models, including the issues of data trust. But we'll come back to you again just now. And we now move to our next panelist, who is Ingrid. And over to you, Ingrid.
Hello, everybody. Thank you very much for inviting me to this panel, and thank you a lot for organizing this two-day summit, which is, I think, very interesting for us to share our ideas all over the world, even if we cannot travel. So thanks a lot, and thanks for everybody who's participating in this session. I would like to use some just 2 slides to show you some of my ideas about evolving business model of NMCA. We heard from Prashant earlier how the environment is changing drastically, and as governmental organizations, we also have to change what we do and how we do it. And that's why I would like to just use a few images to illustrate how I see this for mapping agencies, cadastral agencies, and in particular for my agency, the National Geographic Agency of Belgium. Now, we started as a producer. We were producing all the data from A to Z. So we had photos, and we would walk around the field and draw maps, and then that would be it. And we wouldn't listen to or look at anybody. Would just do our work as we have done it for the past 200 years. Now, at a certain point in time, for several reasons, we understood that it was better. We didn't have the money anymore, we didn't have the people, or there were other reasons, and we saw that it wasn't necessary for us to produce everything. We could also integrate information which comes from others, and in our case, this was information provided by the railroad infrastructure company, or the high tension line regulatory body, or the regional mapping activities in other countries. This can be municipal information or crowdsourced information. And so more and more mapping agencies are not only producing data from starting from scrap, but also using other sources and quality assuring, harmonizing those data into their production, and using those informations to produce national coverage of standardized data. And this is, I think, something that you see everywhere, and with the evolution of technology, more and more. Now, besides this role as a producer and an integrator, where the first steps of integration were using data from others to produce what we wanted or what we did, you see that very soon you get a pressure of, could you integrate these data for another use than the classical mapping activities of cadastre or mapping agency? And so we started being the integrator of data which were not necessarily the traditional reference data, but also other data that were at another scale, another level, or thematical data, or whatever. And on top of that, we also developed what I've called the geo-broker role. And this geo-broker role, it is all about making data accessible and having the government work more with geo-information. And at first, this was, let's say, a small activity more in the background, but today the producer role is shrinking all the time. We don't have to produce a lot of data because there is so much data available. The integration is becoming much more important, and we are more and more playing the role of integrator, standardizing body, or bringing different sources together in one service, so that the client doesn't have to look around and try to find his way into information. And the broker role is growing very fast. And to explain a bit more how we see this broker role, I've made this information. So you have, in our case, the federal government, and there you have people sitting on data and not always opening those data up very easily to the outside world. And so the first role of the geo-broker, in my opinion, is to make sure that governmental data are easy to find, are easy to access, that there are services available, and that whoever wants data doesn't have to know their way around in all the little parts and the different winding roads of government to find the information. It should be easy to get it, and that's a part of the geo-broker role. So get the information which is inside the government and make sure it gets out there to be used by anybody, world users. The second role is, of course, to make sure that this information is also used by the government itself, which is the inside in, it's the internal business of government, but also it's our role to make sure that government makes better decisions by using relevant geospatial information and geospatial knowledge. And there is the second role of the geo-broker, which is look at all the data that is out there that is available and make sure that this data is easy to be used for the governmental officials. And so this is what I call the outside-in role. And at first at NGI, we started with making sure that data was easy to find and that we had one-stop shop contracts for all governmental officials to use certain private information like navigation data or also data from other governmental levels. But now we see that those federal users are asking us to be more, not just a data source, but also a source of help and a source of services so that they can concentrate on their job, which is certain aspects of decision making, and that we provide them with good information and knowledge so they can make the best choices. And that is, of course, something that in the COVID crisis, many mapping agencies have shown how they can contribute to a better decision making. And so just to round up, this is what I see as the evolution for the business models of mapping agencies and cadastral agencies. So evolving from a map producing entity to a facilitator ready to show a lot, ready to help the government to make better decisions. And I've just one more slide to show you. One of the biggest issues for us as a government is that of course, there is a big tendency to say governmental data should be free, and I have no issues with that as long as that there is sufficient funding so that we don't end up in the worthless shop. Because governmental funding is not always easy to get. This can be the case because of the lack of governmental funding, because of the power of the country to provide these kind of budgets, but also because the value of what we do is not always recognized, and it's much more sexy to spend your money on other things than on a geospatial infrastructure underpinning decisions. So I think that's about what I would like to give to the audience as an introduction. Thank you.
Thank you very much for that, Ingrid, for sharing with us your views on the evolving role of the National Mapping Agency, particularly the way they are moving from the previous data capturer now to more a geo-broker role. And I'm hoping that many of the national mapping organizations will take up what you're saying and will not end up in the worthless shop. So thank you for that, Ingrid. And we now move on to Vijay.
Thanks, Derek, and thanks, Prashant and Ingrid, for your presentations. I'm also very grateful to Geospatial Media for inviting us to this forum. My topic is going to be a little different. I'm here to talk about Intel Geospatial, and this is, I think, relatively new business. I'm not sure if many of you have even heard of it. But Intel Geospatial was launched 6 months ago. It was a culmination of about 2 to 3 years of work prior to that. And since launch in October, we continue to iterate on our product and to bring in new customers to our product. So we're very, very excited with where things are, and we're investing in this business. And that actually brings me to very important question. In fact, the first question I get from customers, from partners, and even from friends and family, why is Intel in this business? And really, of course, there is the business potential, but there's also the synergy that may not be very obvious between what's needed in geospatial and what some of Intel's capabilities are. And I look at it as 3 fundamental underpinnings. The first of which is data. And in the geospatial industry, we have data from satellites, drones, manned aircraft, and terrestrial sources. Intel, in fact, has sensor technologies of our own. We have RGB and LiDAR sensors. Some of these get marketed under the RealSense brand name as well. So sensor technologies is one element within data. The second is our fundamental belief that partnerships can bring a lot of value. And we have forged partnerships on the data front with industry players, with what we believe is an assortment of best-in-class data sources. And the third, in fact, it's a topic that was also covered in the previous session, is Mobileye, which is an Intel-owned company that provides data services through a very, very innovative way of collecting geospatial information through terrestrial vehicles. So the first pillar is really that we believe data is something that geospatial data in particular is an area of strength for us. The second is around AI. And over the last several years, Intel has made multiple billions of dollars of investments in AI. And we believe this is a very critical element to take geospatial data and deliver insights, which is what, at the end of the day, is the requirement from our enterprise or government customers. And on the AI front, we believe we have taken advantage of the capability that resides within Intel and repurposed it to be meaningful in the geospatial domain. The third element or underpinning here is the cloud. Intel compute capabilities power the public clouds, all the big players that you're familiar with. What's interesting here is that we believe that a cloud-based approach for our geospatial platform brings both flexibility as well as scale, which is very, very important. So really, we said there's a business potential here, and there's a lot of synergy between what Intel is capable of delivering and what the geospatial industry is asking for. So that's briefly why we entered. I want to spend a moment talking about what Intel Geospatial is. There are 4 bullet points here. I'll spend a little bit of time on each of those. The first is we are an open cloud-based platform. We are hosted on AWS, and what we do here, is really provide a set of capabilities which we think make it easier for our customers and make it more valuable for our customers to engage with us. In fact, across these 4 elements, I think the common theme that I'd like to talk about is democratization. So when you think about the open cloud-based platform, we do 2 things here. One is that we are open, we conform to industry standards, we play well with other products and technologies. And the second element is because the cloud provides flexibility to scale up and down with your computing requirements, we actually also use this to make sure our offerings scale across very, very large customers, but also smaller ones. So we really are bringing geospatial, we believe, the capabilities to a large audience. The second is around geovisual data management. And in this area, we are making an effort to really mask the complexity for the end user. We know that there are GIS experts around the world. We know there are data scientists, but we also believe that there is an unserved community that can really benefit by capabilities that hide all the complexity and focus on solving business problems. The third element, AI-powered analytics. We have analytics capabilities of our own, and in many cases, our customers tell us that's one of the reasons why they have chosen Intel Geospatial. But I think what's very important here is that we are taking an ecosystem approach. We are actually actively bringing on third parties. These are software vendors that have analytics of their own, and we're bringing it to our platform. We believe this collaborative approach is extremely important because at the end of the day, there are domain experts, and Intel by itself is clearly not a domain expert across all of the different areas we need to serve. So by bringing analytics, not only from ourselves, but also from third parties, we are making it possible for our customers to really benefit from analytics, both breadth as well as depth of capability. In fact, it's also worthwhile to point out some of our customers bring their own analytics to our platform. So in fact, they build their own product for themselves in a sense. And then lastly, multi-source 3D data. We've taken great pains to assemble content across RGB, LiDAR, and other data sources. So we're these are nationwide libraries, which we believe are valuable for our customers. And with data, we have libraries. For some of our customers, we take on tasking projects. And several customers also bring their own data. And for us, we are very agnostic to any of these approaches. End of the day, we believe it's about solving business problems, and we believe it's about really democratizing some of the capabilities that we're bringing to our product. So that, in a nutshell, is Intel Geospatial. You can see a visual here. The visual just shows some of the things we do. For example, we have AI that identifies, you can see an electric pole here. We have AI capabilities that identify the presence of the pole, the location of the pole, and also identifies the components that are on the pole. And for some of our customers, we are also looking to address the issue of what is the condition of these assets and components. You can see on this screen, there's some LiDAR data sets. So that's another area where we provide classified point clouds and look to solve key problems like vegetation encroachment. So these are just examples of problems that our customers are able to solve when they come on to Intel Geospatial. I have just one last slide, which is talks briefly about some of the industries we are playing in today. So again, just to remind everyone, only 6 months of existence, but we're already present in at least 3 to 4 verticals. In smart cities, we're working with partners and customers to really find a way of monitoring assets at scale. We do this with very interesting data sources, aerial, terrestrial, and even mobile eye that I mentioned earlier. In energy and utilities, our focus is on answering questions like, what assets do I have? Where are they located? What components exist on those assets? And what is the condition of these assets and components? And how do I go about ensuring that maintenance is predictive and is done in the most intelligent and efficient way? And then, third example is insurance. It's an industry that, frankly, is well served by several existing players. And the flavor we bring to the table here is about bringing innovative AI-based capabilities, analytics, which we think add significant value on top of data sets that are nationwide or global in scale. So several different variants here in terms of how we address different segments. At the end of the day, we are a horizontal platform, and we are very open, standards-based, and always looking for cooperation opportunities, be it with the private sector or with governments for that matter. One last comment. It's been, it's a 5-minute overview of Intel Geospatial. I did want to just leave everyone with this URL, intelgeospatial.com. That's a way in which you can learn more and engage with us. Like I said, we are very, very open and would love to talk to potential customers, partners, and just about anyone who would like to engage with us. So thank you again for the opportunity to present, and I look forward to the rest of this discussion.
Thank you, Vijay. Thank you for sharing with us the reason why a company like Intel is involved in geospatial. That's very interesting applications that you're involved in. All right, we will now move on to our last panelist, who is Joel. Over to you, Joel.
So, thank you. I will speak from Geospatial Infrastructure, one of the most well-known sensor used to know where we are around the globe. It's obviously GPS, GNSS. and we generally we always make the hypothesis that GPS, GNSS will work everywhere, but it's not the case. A lot of places, in a lot of places, it does not work. I mean, in normal buildings, it may not be so important to know where we are in my house or in my office. But when you are underground, when you are inside a subway station, road, tunnel, underground parking, there may be some problems. For example, here I give an example with the security forces in Montreal. Why Montreal? Because it's a town well known for its underground network, corridors, shopping malls, and so on, coming from the fact that they are quite cold in the winter. And then the SPVM, the Police of Montreal, purchased a telecom system based on TETRA standards some years ago, including a GPS chipset, meaning that every policeman, fireman, and so on are located when they are outside. The problem is fire may also occur underground in the subway and so on, and they will lose the location capability, and then they will not be monitored. They will not be in safety anymore, and then this is a problem. This is a point I will address here. So one of the idea is, if I make GPS work underground, all existing GPS receiver by definition will work. I will not ask my fireman or my policeman, or the same for everybody with a smartphone. I will not ask them to have either another hardware or another software in order to have a positioning continuity. Then this kind of system, how does it work? It is based on either on GPS repeater. So I take an antenna outside, I get the GPS signal, and I feed it underground on the underground antenna, but I have to put a lot of antennas. And it can also work here in this example with GPS simulators, which have a much better precision. So the point is, it's similar, exactly similar to telecom infrastructure. I'm speaking from cellular base station that you have outside, and also that you have underground, which are using a distributed antenna network in order to emit their signal. And the GPS, underground GPS, is based on the same concept. It's also possible to share the same antennas and antennas network. And so why should we offer the same capability in terms of location? I mean, underground. At least it was the first point of my presentation. At least to enhance the safety for policemen, firemen, and public agent, but also for everybody. If in many countries, if I call 911 or 112 in Europe, for example, so I'm speaking from emergency call. In many countries, when I call this, I will be located automatically by my GPS chipset when I am outside. If I am underground, obviously I will not. And then the fireman will not be able to find me. On the contrary, if I make GPS work underground, yes, it will be possible. The thing is, this is not totally new. It's an emerging capability. It's quite new, and the very first underground places which was installed was 3-4 years ago in Stockholm, in Sweden. And they wanted to do exactly what I explained here: locate their agent for safety, locate the fireman, and so on. So it was the very first. But since then, a lot of other places, or other country, or other government thought it would be very important to bring this kind of service to everybody. And I have given here at the beginning 2 example of link. We can showing that first in Australia, in New South Wales also, they are deploying such technology, but also in Montreal, in Toronto, and also here I gave just 2 examples in France. So this is really a beginning trend, and again the main advantage is that you will be able to be located. Every service will work. Every acquisition system, every autonomous vehicle will work in underground parking, etc., without any software or hardware change. So when we are speaking from geospatial infrastructure, at least for navigation, we always think of space segment. But if we think of what is currently happening tomorrow, maybe in some years, if we imagine that the 1,000 or 10,000 of underground tunnel will be covered, the hundreds of subway networks will be covered, then this global space infrastructure will be completed by this underground infrastructure. And the most important point, it will be compatible, it will bring continuity, universality, and so on, and obviously a seamless transition. Thank you.
Thank you very much, Joel, for that presentation. It certainly does cover what has often been regarded as a lack of coverage for location data, and certainly is an interesting solution for that one. So thank you for your presentation. Right, we now like to bring on the whole panel to see if there are any questions. I don't know if there are any questions from the audience. Please post your questions. While we're waiting to see if there are any questions coming up from the audience, I will maybe put some to the panelists. Prashant, I'd like to hear from you. What are the types of PPP models that can be adopted for maximum impact?
Well, I think, you can go through the 10 various models that range from traditional PPPs, which, if you think only about collaboration, they're strict contracting arrangements between governments. There are some, I'll just throw some concepts out there. There's build, own, transfer. There's build, own, operate, and transfer. There are traditional procurement approaches. There are lease arrangements. In the report that the WGIC will be issuing shortly, you'll get a full detailed explanation of them. And so watch out for that report. But I want to say one thing about those reports, about sort of those business models. None in and of themselves are a guarantor of success. I think essentially what has to happen in terms of the models is that you have to have the right enabling climate. And context is everything, which is why my presentation really focused on the context of the global economy and the pressures that people are under. And I think that one of the things that makes PPPs particularly appealing at this stage is the global concept, the global context of indebtedness. Each nation state, as a result of the COVID experience, has taken on massive amounts of debt, which will require adjustment in the next 5 to 10 year period, which in my view has significant issues and challenges for the geospatial community. if we want to create sustainability, regardless of the business model, we have to think about how it is we're collaborating together and creating the optimal context for long-term success. So any kind of business model you venture into, you have to have a view on the long term in terms of what you're achieving for citizens, for taxpayers, for your clients, for your stakeholders, for your partners, for your advisory board. All of those components have to come together in a much more holistic view than traditional competitive environments where a focus was on the shareholder, on the return to the shareholder in terms of investments, and the bottom line. So, my view is that any kind of a business model can work. It's just that you have to have experience with the business model. You have to continually refine it. You have to perfect it. And you have to think about the context in which you want to operate. And it may not be a business model. It might be a not-for-profit organizational model that works. The open model, the open data model is a business model in and of itself, and it creates an ecosystem, but it's an ecosystem model. So understanding the ecosystems of business models, I think, is extremely critical. And we're going to have to do a lot of that going forward. And it's not just about the technology and the applications. So we do have to think much more holistically. And success can come in various forms. Thanks for that, Derek.
Right. Thanks, Prashant. We are running out of time, but there is a question from one of the participants. And Ingrid, I'll put this one to you, please, if you don't mind. It reads, a lot of available free government data subject to Creative Commons licenses can be a bit of a minefield to navigate, especially for commercial use. How can this affect business models? Just very briefly, Ingrid.
Yes, well, I must say this is something we are struggling with ourselves, because at the one hand, we would like to, we are pushed into providing more data open and for free, but at the same time, we want people to recognize when is this authoritative data being used within the product or the service that they use. And so it's a difficult issue, and I understand the problem, because often you can see that at least you have to, we work with a CC BY, so you have to mention that our data is included, and this is not easy for people who are integrating those data into other products. In fact, we struggle with the same issue when we are integrating data from our colleagues in an international setting, when, for instance, within Europe, we have pan-European data sets, and we see that some of the open data sets are difficult to include in this product just because they do not allow to be included in a commercial product. So it's certainly something that we have a lot of work to do to get this really operational and running like we want it. And I saw some other questions about the responsibilities and how this stakeholdership will change. And one of the things I think we have to solve is the balance of what is the community information, if I can say it like that. A lot of private companies are collecting huge amounts of data, which would be very useful today, for instance, in trying to monitor and follow up on the COVID crisis. But this commercially interesting information is hidden, is considered to be a commercial asset, and will of course not just be thrown out like that. But at the same time, for the better of our planet, it's important that this information somehow comes available. And so I'm all for open data, but then for everybody's data and not just governmental data. So I think that's maybe a provocative statement, but I would like to see more data available, which is now within the hands of commercial, if it is for a governmental use or a non-commercial use. So it's certainly a lot of things that we still have to discuss. And if I could say what would be my dream, then it's like that with the help of private sector and public sector and voluntary information and other information that we can create like almost a digital twin, which can help to manage better our environment, but which at the same time respects the right of the individual for his privacy and the security of a state, and so on and so on. So there's a lot of things to do, and I'm really looking forward to see how this is growing and going on further, because when we make our data open as governments, often they say, yeah, there is a very big return on investment and you will have your economy will bloom because of all this information which is available, and all the businesses will thrive. And I can see that point. But what they say then is that there will be a return on this investment because we get that that companies are thriving and paying taxes to contribute to the government. But the problem I see is that some companies don't pay taxes, not in my country, not in your country, not in any country, because they have these huge tax evasion systems in place, which from a point of view of the company, I can understand. You want to optimize your assets, but at a global scale, I think it is very problematic. So the return on investment which is proposed or which is projected is not coming because of these mechanisms with these very big world scale companies.
Thank you. Thank you, Ingrid. So it just leaves me to thank our panelists very much for your contributions. And I see there are still further questions coming up from the audience, but maybe those can be responded to offline. So thank you very much. And back to you, Anamika. Thank you.
Thanks, Derek, for taking us through the discussion on co-creating geospatial infrastructure and services and evolving business model. We have set the stage for our next panel discussion. Are we ready for geospatial knowledge infrastructure? We have been hearing about this. So now the discussion will drive, are we really ready for it? And for this, the session is being moderated by Rolando Ocampo, the Statistics Division Director from ECLAC. Rolando, the floor is yours to drive the discussion.
Thank you, Anamika, and thank you to all of you. Dear colleagues, good morning, good afternoon, good evening, wherever you are. Welcome to this closing session after 2 days of intensive and important discussions on a diversity of relevant topics that show us how the GKI is attempting to redefine the data ecosystems and how we can work together to make this geospatial knowledge infrastructure a reality. In this last session, we will be addressing a crucial question. Having reviewed a wide range of concepts and requirements, we now need to respond ourselves. Are we ready for a geospatial knowledge infrastructure? Just to provide an initial reflection before the intervention of our distinguished panelists, I would like to take a couple of highlights from the GKI white paper and put them here for your consideration. The first one has to do with the different steps of the knowledge pyramid that draw the way of our countries and organizations to move towards the GKI from the current baseline situation. What are our strengths and challenges in data management? What are our progress in the generation of geospatial information to respond what, where, and when? Are we advanced in the production of knowledge to provide understanding and deliver capabilities to predict, to know why and how? Are we close to reach the level of necessary shared understanding required to decide action? In second place, I would like to highlight the relevance in the transit from the spatial data infrastructure to the geospatial knowledge infrastructure, with the support of the IGIF implementation guide and action plans. Having an SDI in operation is an asset when looking ahead. The national SDIs will be highly empowered by the IGIF and its 9 strategic pathways: governance, policy and legal, finance, financial, data, innovation, standards, partnership, capacity and education, communication and engagement, It is also crucial to recognize the role of other sectors beyond the government that must play. Means like in the industry, the private sector, the academy, and the civil society among the most important in order to advance toward the geospatial knowledge infrastructure. After sharing these brief reflections, let me begin with the intervention of our distinguished panelists, and just to say that each one of you have 7 minutes for delivering their messages, and once we finish, we are going to have a round of question and answers, and for this and open the discussion. In first place, I would like to give the floor to my colleague Stuart Minchon, who is the Director of the Pacific, Director General of the Pacific Community. Stuart, you have the floor.
Thank you, Rolando. I'm going to be very quick. I want to talk about some geospatial knowledge infrastructure for development, Digital Earth Australia, Digital Earth Africa, and Digital Earth Pacific. So first up, geospatial knowledge infrastructure. Why do we build infrastructure? We build it to support economic activity, and that is traditional with physical infrastructure. We build ports, railways, roads, bridges, energy grids, communication grids as physical infrastructure to support society with the delivery of products and services. We're familiar with digital infrastructure and knowledge infrastructure in general. Every day we get access to the weather report. This is a knowledge infrastructure that tells us whether it's going to rain tomorrow, whether the sun is going to shine, whether it's going to be windy. And this knowledge infrastructure delivers this knowledge in decision-ready products. You do not have to become a meteorologist to understand the weather report. I would argue that we already have geospatial knowledge infrastructure globally in the case of location-aware products and services like our smartphones that make use of GPS to update our location in relation to the physical world. But while we can update our location on a second-by-second basis, we often don't update our conceptualization of the physical world that we're using that location in. And this is where we need to get better at using tools such as Earth observation to update our physical world conception and our understanding of how that's changing on a regular basis to make the best use of our geospatial capabilities. In the Earth observation domain, though, we've been very good at delivering data, and we've been very poor at delivering operational services and decision-ready products. What's the opportunity? This is a study done in 2019 on just the APEC economies, showing that the current value of Earth observations to those APEC economies was $372 billion US, but it was forecast to grow to $1.35 trillion US by 2030. And that's only 10 years away. To give some concept of that, in Australia, that is expected to grow from 20 billion to 66 billion, which is the entire size of the current agriculture sector in Australia. This is really significant numbers and a real reason for building geospatial knowledge infrastructure. I mentioned that our use of Earth observation has been poor. We've been delivering data for many years. So we needed to find a way to turn this measurements from satellites and other instrumentation into decision-ready products. And we developed a tool in Australia to do that. We call Digital Earth Australia, which makes use of data cube technology to turn Earth observations into analysis-ready data and deliver that as decision-ready products for decision makers. Here's an example. Using this tool, we were able to map every water body in Australia that was larger than an Olympic-sized swimming pool. There are 295,902 water bodies in Australia of that size or greater. We can't possibly hope to measure physically 295,000 water bodies across a vast continent like this. But with Earth observations, we can. We can measure which water bodies are full, which are partly full, and which are empty. And we can update that on a weekly basis across the entire continent and deliver that as a tool that doesn't give you necessarily only data, but actually tells you for every water body whether it's full, empty, or partially full at this point in time. This was used very actively during the big bushfires in 2019 in Australia to identify which water bodies had water that the helicopters could use to actually extract. So this is an operational service that delivers decision-ready products. Don't require you to become a remote sensing or geospatial professional to use. You just access the knowledge through the knowledge infrastructure. So the data cube capability, we open sourced because we saw the opportunity to make use of this technology globally. The data that it uses is already available globally. And there's a growing implementation of data cubes across the world. In Africa, we've developed the second continental operational data cube in Digital Earth Africa. And I'm just going to show you one example of a product in Digital Earth Africa, which is in Ghana and is looking at illegal gold mining in Ghana. So here is the Ankobra River. You can see in the center of the screen kind of working its way through Ghana. And in 2017, you can see that there's been a change in that river. That is the scars of illegal gold mining operations in that region. So with the development of Digital Earth Africa, the Ghanaian EPA has successfully prosecuted over 40 illegal gold mining operations and return that, reduce the environmental damage and increase the taxation base for the country through not losing access to that gold over time. And the World Economic Forum recently did a study looking at the economic value of Digital Earth Africa, which made use of this illegal gold mining example, plus a couple of other decision-ready products, to estimate that the value per year to the African economy of Digital Earth Africa was 2.3 billion just using those examples for a cost of only $7 million per year. So $2.3 billion per year of economic value from an investment of $7 million. So what I'll leave you with is a thought about how this could transform our blue continent in the Pacific, where I'm speaking from tonight. Our blue continent is facing real challenges with changes happening to its environment, and that we need to be updating our knowledge of those changes on a regular basis. And SPC is now leading an effort to deliver Digital Earth Pacific to follow on from the success in Australia and Africa. And I really encourage you to think about geospatial knowledge infrastructure being about delivering decision-ready products for users. Thank you. Back to you, Rolando.
Thank you, Stuart, for your wonderful presentation. Now, let me give the floor to my colleague Mimi Martha Schauke. She's the director of the National Spatial Information Framework and at the Department of Rural Development and Land Reform in South Africa.
Thank you, Rolando. Kindly share the slide. And greetings to everyone. Greetings from South Africa. Mine is to assess the South African spatial data infrastructure readiness to deliver the geospatial knowledge infrastructure, because we understand that the South African spatial data infrastructure provides the base data, the foundation data required to deliver the geospatial knowledge infrastructure. I will start with the picture that we are all conversant with. That's the data, information, knowledge, and wisdom. That's the DIKW model. We are all aware of that model, and we understand how NSDIs have been built around the country. They focus mainly on data, how we collect data, and how we provide policies for data, how we provide access networks, and ensure that there are technical standards to promote data sharing and integration. The NSDIs, they also focus on people, but we all know that the focus on people was, for GI science professionals were talking among ourselves to make sure that there are policies, there are standards in place to encourage data sharing, but it was less on, focus on the user. Now we move to the next level, which is what I can call the world new order in geospatial information management. This world new order has got nothing to do with the conspiracy against COVID, but it's got everything to do with how we manage geospatial information and ensure that we have geospatial information for evidence-based decision making. Now, how do we move now from thinking data to delivering an integrated geospatial information? We use the IGIF, which is the Integrated Geospatial Information Framework, to assess SASD readiness or alignment with the IGIF. And the IGIF has got 9 strategic pathways. When you collapse the strategic pathways into 3, you end up with governance, technology, and people. And now taking the South African spatial data infrastructure and superimposing it on top of the IGIF. This is the picture we get. We know that in terms of governance and institutions, we are doing well because we've got the statutory body established in terms of the Act to oversee the implementation of SDI. We've got the legal framework, we've got policies in place in terms of how custodians must manage their data. But we are having challenges on the issue around finances. And we need now to come up with a financial model to project the value proposition to our political leaders to ensure that we get the financial and the leadership support that we require. So something that we need to look at is rate. Now, looking at the technology part, because the NSDI in its nature is established to deal with data and standards, those areas are well taken care of, but we have challenges with innovation. And you'll see how innovation links to the issue of partnership. Partnership on the people issues, we are not doing very well because the establishment of the SDI did not take into consideration the role of the private sector. As much as it's considered the role of the academia, but it left out the citizens and the industry. And issues of capacity building, we are doing well, but we're still talking to ourselves in terms of communication and engagement. Now, a quick comparison between what we have as the results from assessing ourselves against the IGIF and a comparable capability and comparison assessment with what is coming from the GKI. I quickly went and do a quick assessment, and I realized that we scored 8 out of 11. And I can tell you that COVID had a role to play, because the last element that came in as a last minute is the issue around dynamic data coming through crowdsourcing. And it's through COVID that we had projects looking at that, where we get crowdsourcing, and then we're using systems like provided through the Esri platform, like the Survey 123, to collect spatial information. But looking at the picture currently, it's not that bad. We can look at changing the colors, the reds and the ambers to green, and we should be able to be on the right path. Now, how do we change these reds and ambers to green? We need to be reaching new audiences. Reaching new audiences through spatial literacy. We need to start ensuring that we've got leadership support in terms of SDI implementation. We have to create new partnerships. COVID has forced us to create new partnerships. We need to leverage on that. There's the role that the private sector and the academia can play. And if these partnerships models are embedded into the legislation, we don't see them changing when the administration change, but we see them creating value and solidarity. We need to be innovative. How do we become innovative? We need to see policy integration across the entire value chain. We need to leverage on the OIR and maximize the benefits from digitalization. Lastly, most important is the financial part. We need to come up with a financial model that is sustainable. But otherwise, we have too many greens. We have a positive outlook. I think we are ready for GKI. The future looks good. Thank you.
Thank you very much for your presentation, Marole, and congratulations for the number of greens that you have in the GKI for your GKI process. Now let me give the floor to the General Girish Kumar, BSM Foreman Surveyor from General from India. General, you have the floor for 7 minutes. Thank you.
Thank you, Mr. Orlando. Greetings to all of you from India. I'll be talking about how to fast track. You see, our predecessors or other key speakers, they have been highlighting the importance of the GKI. Now, the problem is that in developing countries, how we can fast track the GKI, establishment of the GKI. Now, I'll touch upon main issues like when we first talk about infrastructure, so we talk about the positioning infrastructure. Positioning infrastructure, why it is very important? Because everything on geospatial is based on a reference station, reference term. So mostly conventionally we use GPS in conventional way, which is very time taking, very laborious, and very expensive also. Now, if you want to fast track infrastructure for any country, so the national mapping agencies, they have to take a lead role in doing that. So generally, if the CORS network is established and a joint model is established for any country, then the use of the positioning system, positioning network will really fast track all the development process. And because we know that the GKI is done for the economic development, now how to add value in that? If we can create a positioning infrastructure in the form of continuous operating reference station network and a joint model, then the control work which we use for referencing all our activities can be really fast tracked. And then comes foundation dataset. Before we go to foundation dataset, this positioning infrastructure should be generally done by the government national mapping agencies only, because the investment should come from government. This is where the private sector and other will be more benefited by this kind of infrastructure. Now, second, which is very important for any developing country, is a foundation dataset. Now, why a foundation dataset is very important is it should be authoritative and authentic. Now, who will do that? Again, the national mapping agencies will provide a foundation dataset. But here, the role of the private sector, academia, or industry is equally important, because large number of agencies, whether they are government agencies other than the national mapping agency or the private sector network, they collect a lot of data. But then any country needs a authentic and authoritative data. So that is the responsibility of the government agency or the national mapping agency to provide foundation data to the country at a largest possible scale, especially for the urban areas and the rural areas. They can do it separately, because how to do it fast track? If everything you want to achieve very, very high resolution, it is not possible. But in phased manner, you can always do it. So this is what we have been following in India also, that high priority areas go for very large scale data sets, and for other areas slowly keep building high resolution data set. So stakeholders are more, demand is more, requirements are more, so there will be gap in demand and supply. But in phased manner, any developing country can come up and find their own ways to how to handle this and how to provide GKI for the country. Crowdsourcing here also, it can be one of the main source of data collection, but again it needs to be validated on ground. So that is again the role of the national mapping agency to make sure that every data which collected and integrated is validated and authentic, and then it is serviced to the citizen of the country. Now, having said this, that we have the infrastructure, GK infrastructure, positioning infrastructure, then we have the foundation dataset. Now, then again, we need to provide a good platform from where we can serve the data. Like one of our key speakers said, that we have been only creating data, but we are not providing a digital, a decision-ready system. So now this is where now that we have to change. All the developing countries, they need to establish their infrastructure in terms of servicing the data as a decision-ready system, not as a physical transfer of data to anybody. So here again, in terms of you can provide APIs or as a map service, so that will enhance the use of the data, and at the same time, redundancy of the data, duplication of the data will also get resolved, and all the data will be currently updated as and when it is created, so that every time you are serving a updated data. Now, platform again, it involves so many things, which generally the surveyors or the map makers, they are not very good at it. But then, in terms of the cybersecurity and other policy matters, one has to be very, very careful. So, this any developing country has to look after these aspects also. Then, how we can achieve this? We can go for a partnership. Now, partnership is one of the very good model here if you want to fast track the establishment of the GKI in any country. The partnership, cooperation, collaboration with industry, with private sector, with academia, with other government agencies, with global agencies, with the other neighboring countries or the stakeholders, and anyone who is ready to help. And in terms of partnership, you can really fast track your establishment of the GKI. The one more important aspect is in establishing the GKI is the capacity building. The geospatial in most of the countries is not a recognized sector. Especially, I know about in India, it is not there, and we have already initiated the process that how we can fast track recognition of the geospatial as a core sector. Now, if it is recognized as a core sector, then we need to act on the capacity building, because we need to create a lot of trained, certified manpower. Because every national mapping agency, again, they'll be burdened with the shortage of manpower, shortage of funds. How to come out of all this and find a solution? So capacity building with the again with the partnership of the private sector network, other academic institutions, and other government agencies is a very important aspect for establishing any GKI in any of the countries. So these are some of my views how to fast track development of the GKI in any country, and will be very happy to answer any questions on this. Thank you so much.
Thank you very much, General Girish Kumar, for your thoughts and your participation. Now, let me give the floor to Mr. Matthew Harrison from the British Geological Survey. Matthew, you have thank you.
Hi, yes, thank you. So I have been with the British Geological Survey for 20 years, but most recently I've joined the French Geological Survey. So I'm speaking to you on behalf of as a member of the French Geological Survey right now. So as a geological survey, kind of our outlook perhaps is slightly different. Certainly it's one of the, geospatial is one of the key drivers for the activities of the scientific activities of our organizations. So as a National Geological Survey, kind of we're involved in a bunch of infrastructures. So those kind of research infrastructures in terms of sharing research data and using other organizations' research data nationally and internationally across Europe and indeed across the world. But we also have a public role as a national mapping agency, and we engage in many of the discussions that you would expect. And much of our science around the subsurface is looking at things like the energy transition, critical minerals, construction materials, hazards, etc., things like that. And so I think that maybe some of the thoughts that I can share with you today have a perspective coming from that kind of heritage. One of the things that as part of one of the national mapping agencies is that actually we've been engaged in SDIs since for 15 years now, and certainly I'm very lucky to have been part of the group that actually set some of the rules and standards around INSPIRE in Europe. INSPIRE being kind of the European SDI, which was adopted nationally by the members. And the exciting thing, I think, now is that we can actually look at using that information. We can actually look at some real uses because to an extent, in building an SDI, it was about explaining or showcasing the data that we could make available in interoperable formats. But now we're actually able to kind of get to the reasons for doing that and to actually get to the real users. And I think that actually, the opportunity now is about actually getting to the root of those challenges and to actually be able to do that in an interoperable way. So I've kind of just had a think before speaking today about actually that the knowledge infrastructure really offers us some opportunities, but also some expectations. So in terms of opportunities, actually, many of the audience will have heard about in more academic community about FAIR, so findable, accessible, interoperable, and reusable data. And actually, in conjunction with that and the standards that are available through that we're all working on through OGC, there is an opportunity to do science now that probably wasn't possible before. There are some real standards there to be used about actually cross-disciplinary science, and ultimately, no one science can really address many of the challenges that we face. Another thing that really I think has resonance very much with the geoscience community is the opportunities through working with digital twins. And largely as a geologist, I would argue that actually a digital twin is really just the digital embodiment of a conceptual model that perhaps I've up to now been able to carry around in my head, but now we're seeing the real opportunity of actually being able to communicate that and also share that information with our peers and indeed our users. Internet of Things is another big opportunity. You might imagine that as a geological survey, much of our data doesn't change, and actually, obviously, the geology doesn't change a great deal, but our understanding of it changes on an exceedingly rapid basis these days. And part of that is because of the opportunities brought around by the ubiquity of sensing devices, and also kind of the real-time upload of data from such devices. And there are some really quite interesting initiatives going on right now. Certainly in Europe, we're just in the process with our sister geological surveys across Europe in actually developing some standards through OGC about sharing all of our borehole information. So in France, we probably publish around 1 million boreholes. In the UK, there are about 2 million boreholes published. And these are vast resources because they're insights into what's happening in the subsurface. Actually now, in being able to demonstrate that we can share that information, we can also demonstrate the utility of that information for some of our users. So, and as I said, I think that there's two aspects to some of the discussions here. One is about the opportunities, but I think there's also some expectations upon us as an organization. Open science is something that is talked about, and open science is something that I think that we would all agree is important, but that does ask questions about the reproducibility and the auditability of some of the scientific results that are produced within my community. We need to be able to communicate about those, and that is another aspect. The more we're communicating about with the real users of our information and our data, we're actually requiring more access to the scientists. Perhaps some of my science colleagues would prefer to sit in their office and squirrel away doing work without interacting too much. But actually, that's increasingly not acceptable in this knowledge infrastructure world. Actually, many of those things, that increased availability and interoperability of data actually brings some real opportunities for us as geoscientists in about being able to predict some of the future. And some of those predictions feed into other communities. There are some very clear examples in the smart cities area where actually some of the tunnels that were dug for recent extensions in London to the tube network, for example, they were using the geological models to drive the boring machines, but then those models were being updated in real time as the machines were passing through different geological horizons. So again, there's an opportunity there, and I've heard a couple of times already people talk about partnerships with the private sector. You know, it was the private sector that was actually we're driving the boring machines, but that information and data needs to come back and needs to be available and needs to update our understanding. But you know, we aren't at the this kind of beautiful future yet. I think there are still many challenges. Ultimately, and I suppose I'm quite pleased about this, we still need human inputs, humans to make some of those final decisions. And that's because the data is very heterogeneous. There is still interoperability issues. And I think that actually there is, to an extent, some of our science, especially scientists and especially in the geosciences, aren't perhaps taking advantage of what is possible through the geospatial knowledge infrastructure right now. So to me, this is all points to a really exciting future. I think that actually we've got the tools there. We can build on what we've created and what we've worked on in the last 5 to 10 years. But I think that going back to what Stuart Minchin said at the beginning, that actually we're now ready to embrace what is possible through decision-ready systems, and it's about actually really getting this data used, and I'm really excited about that future. Thank you.
Thank you very much, Matthew, for your thoughts and your comments. And finally, let me invite our dear colleague and friend, Sanjay Kumar, to share his thoughts with us. Sanjay, you have the floor for 7 minutes.
Thank you very much, Rolando. Probably I'll just take 2-3 minutes only to share some of the thoughts because we save this time to have some more interactions. So I would start to say that I really like what Stuart said in the beginning, that the knowledge infrastructure does exist. Now, there's a lot of databases which are available in the open domain, and thanks to various international organizations who have been working towards collating that data and making that data work. But what is more what's happening is the fact that why we talk about geospatial knowledge infrastructure, because as General Giris talked about, there are various components of geospatial knowledge infrastructure: positioning infrastructure, digital platform infrastructure, public policies, alignment with the national ambition. And we need to look at a holistic view of the geospatial strategy. So GKI is a kind of national or international strategy concept which brings together a much larger picture of collaborative strategy for value chain. So and we need to just, I'll take 3 minutes to talk about, is that we need to recognize, first of all, and make an assessment and prospect assessment as well, that what is existing in a country and what are we doing with regards to using geospatial information. What kind of positioning infrastructure we have, what kind of stakeholders we have, make that assessment, and then create a kind of collaborative strategy. And that collaborative strategy of what we used to call about SDI has to come together and then engage and align itself with the national ambition, that what is our role into the national ambition. Every nation has some kind of strategic directions, 10-year, 5-year, 20 years, and connect your existing strategy with the national strategy is something which is important. And then that's when you start getting more attention, that's when you start getting more value for your investment. As Ingrid was saying, that if the government has to invest, we are ready to make it open data, but the government has to invest. But the government has to know that how this information is going to help them pursue their vision. And I would also like to say that, to achieve much more holistic, outcome, one has to be very, very open in thinking. Of course, we talk about open data and things like that, but most important is the open in thinking. And many times we don't move forward because of the kind of restricted thinking. Oh, this is my and that is yours. We have to talk about collaborative national strategy, and then you come to the public policies. Very important point, public policies, and we have just seen an example of that, in the government of India, which took a very visionary step, a map which was absolutely restricted and shackled has been totally unshackled at the highest level of the leadership, the prime minister. But then if you read the preamble of that document, it actually talks about the uses of geospatial knowledge into the national ambition. And when it is connected with the national ambition, that's when the prime minister and the chief economic advisor and many principal scientific advisor, they all sat together and brought this change in the policy. And that's something which is much, much beyond than our expectations. Actually, I must acknowledge that the government has taken much more fast forward strategy than what we were actually aiming at. And this is what is a classic example. It takes time, but it does happen. And I think final thing which I would like to say that it's just a collaborative approach. The GKI is a collaborative approach. It's not something which is a data platform, or it is not something which is positioning infrastructure in itself. It's just a collaborative approach to bring the synergy from various stakeholders and deliver the knowledge as a service. Knowledge as a service. And that knowledge as a service has three categories. One is the consumption by the citizens, which is being done by many organizations around the world, be it private or be it international organizations. But what is important is the geospatial knowledge for infrastructure and engineering. And then the most important, the geospatial knowledge for the national sovereignty and national security. And I think these three different layers of functions does require different layers of investments and different layers of strategy and different, that's what I would like to say, that there has to be a zoom in and zoom out of GKI, that you can be very like consumption level, but then you can get into a very strategic level. So that's one strategy which has to be integrated. Thank you very much.
Thank you, Sanjay, for your thoughts, and you're right and very clear. One of the things that we must think is, what about the link with the national statistical offices that we are working on, in particular from my side? I'm the director of statistics in ECLAC, and I'm trying to join the Geospatial Information and the Statistical and the Statistics, just to have more advances and all those issues. And I remember a meeting that we have in China, and 5 or 6 years ago, I don't remember, the presentation of one colleague from Singapore that mentioned the 3 C's, the 3 big C's, that is collaboration, communication, and cooperation. So coordination, communication, and cooperation. This is an important aspect that we have to face. Let me take 2 quick questions that we have from the floor before we close this session. The first one is for you, Stuart. We have, if you can share with us some ideas and outstanding innovative application based on the Earth observation, sustainability, and biodiversity and ocean governance. During these years before the COVID and after the COVID, what are your thoughts in this regard of these ideas? 1 minute, Stuart, if you can simplify.
Thanks, Rolando. Yeah, look, there are so many opportunities to make use of Earth observations and geospatial information for development. I'm going to talk about the Pacific in particular. We're faced with issues of sea level rise, coral bleaching. We've got COVID has impacted our region very significantly, not so much as a health crisis, because our governments in the region shut their borders very quickly, and actually the region has largely escaped heavy caseloads of COVID, except for a couple of countries. But the economic impact is enormous, and one of the biggest earners in the region has been tourism traditionally, and of course that's disappeared. So the second biggest earner is our fisheries in the region, particularly our tuna fisheries. So using Earth observations to track illegal fishing activity will be a critical use case in this region to ensure that the second biggest economic benefit in the region is actually protected. So there are many ways that this region can benefit from geospatial knowledge infrastructure, and it is something that there's a real appetite for from the Pacific countries, something that has not been focused upon by donors previously. So there's a huge opportunity to assist the Pacific in stepping up in this space. So I encourage you all to engage.
Thank you, Stuart. And I have another question for the General Girish Kumar. The question is, how has geospatial knowledge infrastructure changed how to survey of India? How survey of India provide information, and how the customers in India consume your information?
Thank you, Rolando, again. In India, National Mapping and Survey of India is the national mapping agency, and we are the oldest in the world. We have completed 252 years. So we had a lot of data, very huge information knowledge network we had. So now what we did, slowly and slowly, we have converted the entire data into an information, and we were servicing Survey of India is providing the data to the citizen through a portal. We have kind of public portal. Then there is a separate portal for G2G, government to government network, and then we provide some of the agencies who are not able to consume the services like APIs or the map service. Then even we do transfer physical data also. So we have the services for the citizen. We have the data for information for government agencies, for academic institutions, and for others. And we have also started initiative we have taken to establish positioning infrastructure in terms of the CORS and the joint modeling in last 2 to 3 years, because these are very critical information. I say that for any GKI in any country, the positioning infrastructure is very critical. All your geospatial data will be referenced to that. If it is not properly referenced, then the different data sets, they will not talk to each other, and it will be very difficult for them to integrate the data sets. So this is what we have done in India.
Thank you very much. Let me ask Marwale Mimi just a quick question. What are the action areas to be immediately addressed for the evolution from your national HDI to the GKI in South Africa? Can you give me a quick idea just to continue this conversation?
Thank you very much. I think from the South African perspective, the issues that need immediate attention and actions to be taken, one is the issue of partnership. The current SDI does not accommodate the private sector. So the issue of extending partnerships to the private sector, to the academia, to the citizens is quite important. Secondly, the issue of capacity building and knowledge sharing. If we address knowledge sharing and capacity building, we'll definitely deal with the issues around innovation. And innovation comes very important when you look at the IGIF. And again, the most important thing is the issue of collaborative engagement or value chain. So we need to ensure that we map our collaborative value chain, and we ensure that as much as you talked about the 3 C's, collaboration, cooperation, and coordination, maybe there's another C that is coming in, and it's communication, which now looks at the issues of communication and engagement. We need to engage our partners, we need to engage our leadership, we need to engage the academia, we need to collaborate across the board. Thank you.
Thank you. And lastly, very quickly, let me ask Mark Harrison, how can countries with higher geospatial maturity help developing countries for the development and fast tracking of the GKI? So how can countries with higher geospatial can support the development countries in this process?
Thank you for the question, Rolando. So I think that actually I've got a very clear example of how that can work, and that is that I'm very lucky to lead a group called One Geology, and this is of all the geological surveys of the world, well, nearly all of the geological surveys of the world, about 186 organizations that are actually working together to achieve a common level of understanding, of sharing of knowledge and experience and expertise. And just last week, I think the week before last, I led a workshop about digital twins, and 7 continents sent virtual delegates to the workshop. And we had some really interesting and really useful exchanges. Actually, some of my colleagues within the Geological Survey, within the French Geological Survey, don't engage at that level around digital twins, but I was able to do that with some colleagues from around the world. So I think that there were some real tangible examples. There were plenty of general examples as well. But
thank you, Matthew. And finally, let me give the floor to Sanjay Kumar just to close this session and close the summit in this process. Thank you very much for the invitation, Sanjay, and all your colleagues. And thank you very much to all of you, Stuart, Matthew, Marwale, General, to attend this wonderful final session. Sanjay, you have the floor.
Thank you very much, Rolando. And I would like to begin saying thank you to each one of you. Right from Chile to Pacific, we have panel in these different time zones. And it's not easy. I know that how difficult it is to put on a tie at 3 a.m. And I think that's true for Stuart as well. But he has a luxury of having a very bright color shirt. Love that. I must say that it's been very, very satisfying 2 days of about 8 to 9 hours. And what we got is the debate, deliberations, exchange of thoughts, ideas, and willingness to contribute together to make this whole initiative take forward. And I just said that GKI is not a kind of a technology architecture. It's a kind of collaborative approach towards bringing stakeholders together to make something which is more useful, meaningful, and take that and knowledge and implement into their strategies, learn from each other. And I'm so happy about it. We started this whole initiative of discussion from Stefan, which talked about sustainability of everything and digital divide and leaving no one behind. Those are the global goals. Bridge the digital divide is so important. That kind of questions came in. I don't think that GKI is going to be addressing all that, but what I'm trying to just say that GKI is just a connectivity of geospatial with digital. And more at the early stage we connect geospatial with digital, better we are prepared to bridge this digital divide gap. And I think it's very important to collaborate in that direction. Second important point which came out is the data integration. Data integration not only within geospatial community but mainstream sectors of information networks and developing those kind of data ecosystems, multi-stakeholder partnerships. I think this session was this summit was very clearly indicating about the new entries. We had a lot of users who came and spoke. We have mainstream engineering and IT companies who came and spoke. So that's the kind of extending the scope of collaboration of geospatial community with the mainstream IT, mainstream engineering, mainstream political and economic leadership. And that's what GKI is aiming to. And that was one of the recommendations as well, that taking conversation into wider government and industry. Important thing which I felt was that proper recognition of the public policies. I think value has been, discussed a lot. Stuart talked about a lot of good numbers, and that's the real numbers. Believe me, I am in that business, so I understand that what is the economic value. We just did a study for Dutch government, which was saying that, geospatial economy of Dutch government, that is tiny country, is 5 billion euros, and its impact into the economy is about 30 billion euros. And that's the kind of numbers which we are talking about, and that's the kind of number impact our community has been making. So once we bring that geospatial knowledge infrastructure in our strategy, we will be able to make much more impact in the whole initiative. And last thing which I wanted to talk about is that there's been a lot of debate on democratization and liberalization of data. I think that's been happening. More and more, openness is happening, and we are collectively making a difference. We are collectively cooperating better, and though we need to do more, but we are on the right path. With this, I would like to thank our partner, United Nations Statistical Department, and various other partners like USGS, BRGM, GeoNovum, Singapore Land Authority, Trimble, Wolpert, International Center for Integrated Mountain Development, Foundation for Social Ecology. When you look at these partners, you'll get to see that how broad range of partners who are co-funding and co-creating this concept, and we are going to expand that partnership to more organizations in times to come. And we are developing next phase of GKI transformation models, and we'll be hopefully able to deliver this training program sometime in the second half of around the second half of the year, because that kind of training program of 5 days, I don't think that we'll be able to take it virtually, because a lot of our colleagues around the world, especially in the developing countries, still struggle with a lot of bandwidth, and we want to really make that more useful for all of them to be in person. So with this, I would like to thank my colleagues, Anamika, John, who have been working on this very tirelessly. I must say that I want to just request you all to reach out to them, thank them for their lot of work. They've been wonderful team, and thank you very much, and have a great day. Thank you very much.